Hello, everybody. Hello. Hi, everyone. Hello, my dear students. Hello, Nurandhariki. How are you all? I hope you're doing well and fine. Okay. Chapter Okasari. Is my audio video all clear, all of you? Everything clear, kada? Or is there some delay? Hello. Hi. Am I audible? Is everything synchronized, students? Check cheskondi okasari and then we will be starting with the session. Okay, great. Great. So, ఈ చాప్టర్ స్టార్ట్ చేసే ముందు there is a pinned comment in your chat section. Okay? దీంట్లో you have the entire test series for simple harmonic motion. Good afternoon everybody. Good afternoon. Very good afternoon andariki, and we will be starting with our topic. Okay? But before that, as I told you, in the pinned comment of this chat section, hi, good afternoon. Yes. So in the pinned comment, there is this test and there mock tests are there. You go after each chapter complete chesina tarvata, you go and attempt this. Okay? Perfect. So I think we can start the session. Good afternoon. Hi. Good afternoon, Parimala. Very good afternoon. Okay, so I think we can start the session. All right. Simple harmonic motion. Chuskondi. When you are starting this chapter, immediately after SHM, you have waves. Okay? You have waves. Ante ee waves chapter lo there is absolutely application of simple harmonic motion. And if your simple harmonic motion is not good, your waves, I guarantee you, if your simple harmonic motion is not good, your waves will also not be going to. Hi everybody. Hi, very good afternoon. Dan tarvata, as soon as you complete your waves, you have one more chapter called as wave optics. Okay, and this is the entire branch of your physics. ఈ మూడు chapters లో they call it waves and thermodynamics. కానీ okay, you have something known as waves అంటే your oscillations, your waves and your wave optics. All three of them, they are interlinked. So if you are missing any one of them, you are definitely going to feel the consequences in the another chapters. Okay, so you can at least expect 4 to 5 questions. Okay, in your NEET 2026, and it is approximately equals to 20 marks. 20 marks ante enti sir? Your 20 marks roughly decide your rank by, if I'm not wrong, at least by 15 to 20,000. So if your rank is 15,000, it could go to 30,000 just because you have not studied these 3 chapters. Okay, hi Isha, hi. Good afternoon andariki. So Jagrataka, as soon as the chapters have been completed, make the perfect notes. Okay, notes ante ee notes lo your each and every formula must be there. Okay, mottam formulas undali. Hi Kanmani, very good evening. Okay, these 3 chapters, and to be honest, I will also be taking these chapters in a flow. And ee roju we will be completing SHM, repu we will be completing your waves, and dan tarvata we will be completing wave optics. Okay, so on Sunday, if possible, if we get the holiday, I will be trying to complete your mechanics. Mechanics lo we are only left with one single chapter, fluid mechanics. Ade, after that your mechanics will be completed. Your electrodynamics lo we are left with your alternating current, EM waves, 2 chapters I believe. Yes, 2 chapters in your electrodynamics, 1 chapter in your mechanics. That will be completed on vacations ante Sunday 26th of January is the holiday kada. Yes, 26th of January we will be completing fluid mechanics if possible. దాని తర్వాత ఎనీ సండే we will see, and ఆ సండేలో we will be completing your remaining 2 chapters, మిగతా 2 chapters from your electrodynamics. Okay, ఇప్పుడు you understand the flow of the discussion. I'm just explaining you the flow of the discussion, all of you. Initially we talked about mechanics, దాని తర్వాత we talked about electrodynamics, ఇదే కదా. If you remember my units and dynamics video, units and dimensions video, what did I say? Electrodynamics. What did I say? I told you that these are the bulk అంటే తెలుసా, these are the boss figures in physics. Either 2 branches ra. First is your mechanics, electrodynamics. You can at least expect somewhere around, not 40, I would not say 40 marks, somewhere around 40, yeah, somewhere around 40 marks. Under 10 questions ra, 10 questions. And here you can at least expect somewhere around 30 marks. Under you can at least expect 6 to 7 questions, 7 to 8, లేదా 7 to 8 questions. Your 70 marks are already getting confirmed in this region only, okay? In this region only. Your modern physics contributes to 30, somewhere around 30 marks, your modern physics. If I'm taking a rough approximately range, 40 to 50 marks here, 30 to 40 marks here, and your modern physics, okay? Your modern physics at least gives you 7 to 8 questions, okay? 7 questions, at least 7 questions. So approximately 30 to 40 marks from your modern physics. Choose 40, 40, 80, 80 plus 50, 130. 130 marks have been completed only in these 3 branches. Ardhamaindi? ఇప్పుడు your 50 to 60 marks of flexibility will be there in the remaining branches. అంటే మీ thermodynamics, heat and thermodynamics, waves and optics, and geometrical optics. Ade. The only branches that will be left is those 3. Okay, good. I request all of you to go through all the videos that we have covered ra. Dan tarvata you make proper notes, and once the syllabus is completed, mostly by mid-February, ade, max to max we will stretch it by 20th of February. 20th of February ante that will be the last day of your syllabus. February last week nunchi we will be starting to solve PYQs. Aa PYQs lo kuda I will be only focusing on your last 20 years of PYQs in NEET. Okay, and then we can at least take around 2022 to 2025 of JEE mains. I will try to include that also. Okay? So if your theory is good and your question solving has also been completed, at least sit relaxed and expect 140 plus marks in physics. Okay, good, very good. With that being said, students, start cheddam. Today's topic ante simple harmonic motion. I should not wipe it up actually. SHM kuda antaru, okay? So I can classify, okay? Anyone there? Okay, perfect. I can classify my motion into 2 types ra, okay? When it comes to oscillatory motion leda or periodic motion can be classified into 2 types. Leda your motion also, it could be classified into 2 types. Okay, the first type is your periodic motion, sir. What is periodic motion? And what is oscillations? Second type is your oscillations. What do you mean by hi, good afternoon, all of you, good afternoon. When I say periodic motion and when I say oscillations, let us start from oscillations. Now, oscillation ante enti, sir? It is simply the to and fro motion. Are you understanding? To and fro motion. That means the object could either go back and forth in one line ra. One line ante telusa. The best example is your springs example. Chuskondi. So if this is your spring ra, okay, and I'm attaching a block of mass m and you're pushing it, students, jagrata. If you are pushing this block to the right, emaitadi ante this spring will pull it to the left and the motion continues like this. Ante back and forth kada, to and fro motion unte, you can call it oscillatory motion, okay? You can call it oscillatory motion. This motion is in 1 dimension. Andariki. So this oscillatory motion is in 1 dimension kada. What about 2-dimensional motion ra? 2-dimensional motion ante the swing ante telusa. So this is a swing, a person is sitting on it and it is moving something like this. Okay, leda a pendulum kuda it can also be classified into your oscillatory motion. Okay, your pendulum kuda it is a special type of oscillatory motion. Your pendulum లేదా your spring block system. Okay, what about the periodic motion then? Periodic motion ante the motion that repeats itself after a certain time. Ante is it repeating? Yes, it is repeating. Is it repeating? Yes, ఇది కూడా రిపీట్ చేస్తున్నారా అంటే these two they are already periodic motions. కానీ there are some cases which are not to and fro. For example, a rotation of earth around sun. Okay, rotation of earth around sun. Leda your clock of the hands, okay, minute clock, second clock. So it is 12, it is 3, it is 6, it is 9. Okay, whatever it is. They are repeating after certain time, ra. It should be 6, right? It looks like R, kada? Okay. So they are repeating themselves after some time. Kani, we cannot say that these are oscillatory motions. Adamindi. Good afternoon, andariki. Very good afternoon. Yes. So, simple harmonic motion ante it is a type of oscillation. Oscillation ante enti sir? It is an oscillatory motion in which the object moves back and forth. అర్థం చేసుకోండి అందరికి. Okay, the object moves back and forth. అంటే let us take an example then. Okay, let us take an example then. కానీ when I'm talking about this example, I want all of you to listen and tell me the things that I ask you. Okay, జాగ్రత్తగా వినండి రా అందరికి. Let us say this is my particle. Okay, ఇదే నా particle, mass is m ra, and it is moving in a linear oscillatory motion. Linear oscillatory motion అంటే ఇది కదా linear oscillatory motion లేదా linear oscillations అదే. Okay, it is moving in linear oscillatory motion లేదా linear oscillation. How is it moving ra? Let us say it is moving in a horizontal direction. It also has multiple options కదా. చూసుకోండి జాగ్రత్తగా. అంటే ఇట్ క్యాన్ మూవ్ హారిజంటలీ లేదా ఇట్ క్యాన్ మూవ్ వర్టికలీ, అప్ అండ్ డౌన్. చూసుకోండి ఇది కూడా టు అండ్ ఫ్రో మోషన్ కదా. ఎస్, లేదా యూ కెన్ సే ఇట్ ఈస్ ఆల్సో మూవింగ్ సంథింగ్ లైక్ దిస్. లేదంటే ఇదే. యూ క్యాన్ డిఫైన్ ఇన్ఫైనైట్ పాసిబిలిటీస్. కానీ ఈ మొత్తం దే డూ కమ్ అండర్ యువర్ లీనియర్ ఆసిలేషన్స్. అంతే కదా. ఎస్, యా ఆసిలేషన్ ఇదే అంటే చాలా ఇంపార్టెంట్ టాపిక్, చాలా ఇంపార్టెంట్ సబ్జెక్ట్. ఎందుకంటే ఇఫ్ యువర్ ఆసిలేషన్ ఇస్ నాట్ గుడ్, యువర్ వేవ్స్ విల్ నాట్ బి గుడ్. ఇఫ్ యువర్ వేవ్ ఇస్ నాట్ గుడ్, యువర్ వేవ్ ఆప్టిక్స్ అంటే తెలుసా? వేవ్ ఆప్టిక్స్ లో వి టాక్ అబౌట్ యంగ్స్ డబుల్ స్లిట్ ఎక్స్పెరిమెంట్, ఇంటర్ఫెరెన్స్, కన్స్ట్రక్టివ్, డిస్ట్రక్టివ్, అండర్స్టాండింగ్ ద ఇంటెన్సిటీ, మాక్సిమా, మినిమా, ఫ్రింజెస్ అండ్ ఆల్ దీస్ థింగ్స్ వి టాక్ అబౌట్ దేర్ ఇన్ వేవ్ ఆప్టిక్స్. ఓకే, చూడండి. So this is the mass and this is ఇప్పుడు some positions define చేస్తాం. చూసుకోండి, some positions we are going to define. I'm going to define some positions. చూసుకోరా. The first is your mean position. Okay, the first is mean position. And what about the other? చెప్పండి అందరికి. Mean position. The second is your extreme position. The second is your extreme position. What next, sir? If the object is between mean and extreme position, it will be considered as a general point. Okay, general point. Very good. Okay, what about ఇప్పుడు when it is moving, we will have to observe three things ra. మూడు observations ఉండాలి. చూసుకోండి. The first one is we will be talking about the position of the particle. Okay, ఇదే నా first positive note, position. Okay, ఇదే నా first observation. What is it, sir? Position of the particle. The second observation is the velocity లేదా the speed of the particle. Okay, velocity or the speed of the particle. And the last observation that I will be doing is the acceleration of the particle. Ante basic observations that we did in Newton's laws of motion. Ide kada? Yes. We will be observing the position, we will be observing the speed and the acceleration, all three at the same time. Andariki. Okay? Good. Very good. So ఇప్పుడు let us talk about the particle position. చూసుకోండి, ఇదే నా mean position. The particle moves towards the right. This is the extreme position. Okay, this position is the extreme position. Ante as soon as the particle reaches this point, it will come back. Okay, and when it is coming back, it will not stop here, it will go back again, something like this. It is going backward, something like this. Okay, and this is another point where the particle is changing its position. Ante direction of motion, extreme position. అర్థమైంది? And this is my mean position. చూసుకోండి అందరికి. So these two are extreme positions and the second central position is known as the mean position. అంతే కదా? Yes. ఇప్పుడు let us talk about the general position of the particle ra. General position ante let us say particle started from the mean position and it is started moving towards the right. Okay, condition చూసుకోండి రా. particle started from mean position. Okay, particle started from mean position and moving towards the right. అంటే ఏంటిరా, after some time if you observe the particle will be somewhere here. ఇదే కదా? Yes. నాకు పొజిషన్ అంటే నాకు తెలుసురా, here is the position. Mari, what about the speeds and what about the acceleration? What about the speeds and what about the acceleration? What about the speed and what about the acceleration? Cheppandi. So speed gurinchi maatladte, your particle has to go to the extreme position kada. Ante what is the destination ra? Destination ante ide extreme position. The particle has to go to the extreme. Ante the speed will be directed towards the right. Enduku sir? Because the particle moves in physics lo it is a established fact. What is the established fact ra? Whenever the particle is moving in any direction, ఏదైనా డైరెక్షన్ తీసుకోవచ్చు, the speed must be same. ఎందుకంటే speed gives rise to the position లేదా displacement కదా? Yes. So sir, if its speed is towards the right, that only means that it is moving to the right. అదే కదా? If the speed is towards the left, it cannot move to the right ra. అర్థమైంది? Yes. If its speed is towards the right, it cannot move to the left. అంటే మీ స్పీడ్ కూడా it must be towards the right side. ఇదే మీ స్పీడ్ v రా. Observation number 1 completed కదా? Started from mean point, moving to the right, అంటే కొంచెం సమయం తర్వాత the speed is towards the right. Understood? Sir, what will happen? Hey, చూసుకోండి జాగ్రత్తగా వినండి. What will happen if the particle touches the extreme position? Ante the particle will come at this point. Chuskondi. What will happen if the particle comes at this point? So when the particle is coming at the extreme position, a small time kosam ra chuskondi. For that small time, can I say speed is equals to 0? Andariki. If I am throwing this pen vertically up ray, topmost point lo what we say is the speed of this pen is 0. Ide kada? Yes. Topmost point lo we say that the speed is 0. Ante extreme points, whatever motion it is ra, make your concepts clear. Okay, make concepts clear ante mc square. Jagrataga vinandi. Whenever the particle, not only in simple harmonic motion, physics lo maamulga ekkadaina chuste, if the particle is changing the direction ante entira, ante it is coming exactly 180 degree reflection. Ade kada? You imagine something like this. Particle is moving down and then it is coming up. Ante this point. Particle is moving towards the left and coming right. Ante this point. Particle is going like this and coming back. Ante this point ra. ఈ మొత్తం పాయింట్స్ కోసం you can simply say that the instantaneous speeds of all of those points is going to be 0. ఇదే కదా? Yes. The instantaneous speeds of all these points are going to be 0. అంటే ఎక్కడ కూడా చూడండి, the particle is going to the right, coming back. అంటే ఈ extreme point లో speed is going to be 0. ఇదే కదా? ఇదే కదా? Yes, yes, yes. Very good. ఇప్పుడు చూడండి. So if the particle is starting with some speeds రా, అందరికి జాగ్రత్తగా వినండి. I do have some speed. ఎందుకు సార్? Because the particle has to cover some distance. And this is the distance that the particle has to move. And at the same time, extreme position lo, the speed is getting 0. Ante, sir, random values nunchi it is going to be 0. Ante speed is, sir, random value of v is there. A random value tarvata, extreme point lo, the value of speed is getting 0. Ante, can I say that e motion kosam, during this motion, can I say that speed is increasing? Speed is increasing. అదే కదా? Speed is increasing. You see, sir, the final speed is 0, sir. You take some general value and let us say assume the speed is 3 meters per second. Random values తీసుకున్నావు చూసుకోండిరా. 3 నుంచి 0 వరకు the speed is decreasing కదా? Yes, the speed is decreasing. That means now I want you to move to the negative acceleration. Gurtunda? Do you know something about retardation? We talked about kinematics 1D lo, we talked about it, right? When the object is thrown upwards, the speed decreases. Ante acceleration is negative. Sir, acceleration is negative ante enti ra? That means the direction of acceleration should be opposite to the direction of speed. తెలుసా? ఓకే, అంటే మీ స్పీడ్ డైరెక్షన్ చెప్పురా ఒకసారి. స్పీడ్ ఇస్ టు ద రైట్ సైడ్. అంటే డైరెక్షన్ ఎక్కడ ఉన్నావు? వేర్ ఈస్ ద డైరెక్షన్? సార్ ద డైరెక్షన్ ఆఫ్ యాక్సిలరేషన్ కి డైరెక్షన్ ఇట్ మస్ట్ బి టువర్డ్స్ ద రైట్, లెఫ్ట్. సారీ, మీ స్పీడ్ ఈస్ టువర్డ్స్ ద రైట్, మీ యాక్సిలరేషన్ టువర్డ్స్ ద లెఫ్ట్. అర్థమైంది కదా? అంటే దిస్ ట్రెండ్, what trend, sir? Speed and acceleration, they are opposite. Each trend, it will continue for the entire motion. Ekkadaina the particle is, the speed and acceleration will be opposite. Jagrataga చూసుకోండి. Okay, అంటే ఏంటి sir? At this point, I'm not saying that it is the fact. I want you to understand if I am true or I'm not true. అంటే am I telling true or not true ra? The statement is for the entire motion speed and acceleration are opposite in direction. True or false? చెప్పండి. True or false? For the entire motion, ఈ మొత్తం మోషన్ కోసమే మీ స్పీడ్ అండ్ యాక్సిలరేషన్ డైరెక్షన్ దే ఆర్ ఆపోజిట్ టు ఈచ్ అదర్. Is it true or false? చూద్దాం. Okay. So sir, let us say to the left of the motion. ఇప్పుడు రైట్ కోసం డిస్కస్ చేసిన కదా, ఇప్పుడు లెఫ్ట్ కోసం చూసుకోండి. సో ఇదే నా మీన్ పొజిషన్ రా, ఇది గుర్తుపెట్టుకోండి. ఓకే, పొజిషన్స్ గుర్తుపెట్టుకోండి. మీన్ పొజిషన్, దిస్ ఈస్ ద ఎక్స్ట్రీమ్ పొజిషన్, దిస్ ఈస్ ఆల్సో ద ఎక్స్ట్రీమ్ పొజిషన్. అంటే వాట్ ఎవర్ ద పార్టికల్ ఈస్ మూవింగ్, ఇట్ ఈస్ మూవింగ్ బిట్వీన్ ద టూ ఎక్స్ట్రీమ్ పొజిషన్స్. అంతే కదా? ఎస్, రైట్. ఇప్పుడు చూడండి, హియర్ లెట్ us talk about this point. Okay, let us talk about a general point. అంటే here, this point. Particle started from mean position, moved towards the right. Ante it moved to the right side, went maximum displacement ante extreme position kada? Yes. Ee extreme position lo speed became 0. Dan tarvata it returned to the left side ra. Enduku sir? Because the acceleration was in the left. Chuskondi. If the acceleration is not acting ra, the particle's speed will not decrease. Ante it will keep on moving till infinity ra. Ardhamaindi? So if you have to change the speed, లేదా to decrease the speed, meeku acceleration kavali. That acceleration should also be opposite to the speed. Ante kada? Yes. So ee extreme point lo chuskondi, ee extreme point lo acceleration keeps on acting to the left. Ee acceleration the acceleration is acting toward the left, and due to this acceleration, ఇప్పుడు the particle will start towards left. జాగ్రత్తగా వినండి. What did happen, sir? Started from mean point, moving to the left, right side. కానీ స్పీడ్ రైట్ లో ఉంటే యాక్సిలరేషన్ ఇస్ ఇన్ ద లెఫ్ట్ సైడ్. ఈ యాక్సిలరేషన్ వల్ల ద స్పీడ్ విల్ డిక్రీజ్, ఇట్ విల్ డిక్రీజ్, కమ్ బ్యాక్ టు జీరో. అగైన్ మళ్ళీ ఎక్కడ కూడా ద యాక్సిలరేషన్ ఇస్ యాక్టింగ్ ఇన్ ద లెఫ్ట్ సైడ్. అంటే ద స్పీడ్ నౌ విల్ సపోర్ట్ ద యాక్సిలరేషన్. అంటే ద పార్టికల్ విల్ స్టార్ట్ మూవింగ్ టు ద రైట్, లెఫ్ట్. ఇప్పుడు యాక్సిలరేషన్ ఇస్ ఇన్ ద లెఫ్ట్, speed is also in the left, so the direction of acceleration and speed, they are the same. Ante the speed of the particle ee case lo ippudu the speed increases ra. Ante sir speed increases, it comes to the midpoint, ante mean position ra. Ee mean position okasari mean position cross chesinante you can simply say sir speed is here, మరి యాక్సిలరేషన్ ఎక్కడ రా? Where is the acceleration, sir? Sir, ఇదే నా extreme position కదా? Yes. So this is your extreme position. ఈ extreme position ఉంటే the particle must stop here. అంటే the speed of the particle must become zero రా. అర్థమైంది కదా? The speed of the particle must become zero. అంటే ఈ పాయింట్ లో కూడా the speed is zero. కానీ when it crossed the mean position, the speed of the particle was to the left. And here it is saying zero ra. Ante emaitadi? There must be the decrease of the speed for this motion also ra. Ante speed is decreasing. Ante enti ra? Ippudu the acceleration should be acting opposite to the speed kada? Yes, so the acceleration must be here. Chuskondi. Sir, what about right side, sir? రైట్ సైడ్ లో చూపిస్తే యూ కెన్ సింప్లీ సే స్పీడ్ టు ద రైట్, యాక్సిలరేషన్ టు ద లెఫ్ట్. ఒక్కసారి ద పార్టికల్ క్రాసెస్ మీన్ పాయింట్ వన్స్ అగైన్ అండ్ మూవ్స్ టు ద లెఫ్ట్ సైడ్, ఎక్కడ యూ కెన్ సే దట్ ద స్పీడ్ ఇస్ టు ద లెఫ్ట్ కానీ యాక్సిలరేషన్ ఇస్ టు ద రైట్. అంటే ఏంటిరా? అంటే యూ కెన్ సింప్లీ సే సార్ ఇఫ్ అట్ ఆల్ దిస్ ఈజ్ యువర్ మీన్ పాయింట్. జాగ్రత్తగా వినండి, ఇదే మీ లెఫ్ట్ ఎక్స్ట్రీమ్ పాయింట్ కదా ఎల్ఈ, అండ్ దిస్ ఈజ్ యువర్ రైట్ ఎక్స్ట్రీమ్ పాయింట్ ఆర్ఈ. ఓకే, రైట్ ఎక్స్ట్రీమ్ పాయింట్ ఆర్ఈ. When the particle is in the right side, చూసుకోండి, when the particle is in the right side, రెండు possibilities ఉన్నాయి. First possibility is the particle is actually moving to the right, కానీ the acceleration will be towards the left. అంతే కదా? Yes. ఒక్కసారి the particle has reached your right extreme, దాని తర్వాత acceleration will be left రా. ఎందుకంటే it has to move. ఇప్పుడు the speed has to increase కదా? Yes, acceleration should be towards the left. కానీ ఈ పాయింట్ తర్వాత the particle is returning back అంటే speed should also be in the left side. Okay? Yes. Perfect. So your speed must be to the left also. చూసుకోండి, ఈ ఏదైనా తీసుకోవచ్చు కానీ the acceleration in the right side, the acceleration in the right of the mean position is towards the left. కానీ ఇక్కడ చూడండి, ఒకసారి ద పార్టికల్ క్రాసెస్ దిస్ మీన్ పొజిషన్ టు కమ్ ఇన్ ద లెఫ్ట్ సైడ్ లో చెప్పండి అందరికి. సో ద పార్టికల్ దేర్ ఆర్ ఎక్కడ కూడా రెండు పాసిబిలిటీస్ ఉన్నాయి రా. ద ఫస్ట్ పాసిబిలిటీ పార్టికల్ మూవింగ్ సంథింగ్ లైక్ దిస్. ఓకే, ఫ్రమ్ మీన్ టు లెఫ్ట్ ఎక్స్ట్రీమ్ రా, ఫ్రమ్ మీన్ టు లెఫ్ట్ ఎక్స్ట్రీమ్. ఈ కేసులో మీ స్పీడ్ ఈజ్ ఇన్ ద లెఫ్ట్ సైడ్, కానీ it is moving, but the condition is that in left extreme low the speed should be 0, and here also right extreme low speed should be equals to 0. Ide kada? So if the speed is becoming 0, ante whatever the speed was having, it should decrease ante the acceleration should be negative, ante opposite direction of acceleration. Ide na first possibility. Na second possibility lo cheppandi andariki, na second possibility lo the particle comes to the left extreme, dan tarvata it will move to the mean position. Ante the particle will now try to move to the right. Kani eesari kuda the acceleration is only responsible for moving this block to the right side. Ante ide na speed and this is my acceleration only. Ante what are the conclusions, sir? No, Parimala, that depends. If your speed is in the left side, అక్కడ కూడా రెండు కేసెస్ ఉన్నాయి. లెఫ్ట్ సైడ్ లో స్పీడ్ అంటే దిస్ ఈజ్ ఫస్ట్ లెఫ్ట్ సైడ్ స్పీడ్, అండ్ ఎక్కడ కూడా ద స్పీడ్ ఈజ్ ఇన్ ద లెఫ్ట్ సైడ్. చూసుకో. సో దేర్ ఆర్ 4 డిఫరెంట్ కాంబినేషన్స్. అంటే ఏంటి సార్? your left side and your right side. Jagrataga vinandi. Your speed could be in the left. Your not left. Okay. Let us talk about this classification. Your speed, your acceleration. At the same time, speed could be in the left. Acceleration is also in the left. Possible. Example, sir. Speed in the left, acceleration in the left, until the particle is moving back to the mean point. Next, sir. If your speed is to the left and acceleration to the right, is it possible, Ra? Is it possible? Yes, it is possible. Chuskondi. Speed to the left, and it should be in the opposite half. Chuskondi. Speed left, acceleration left, until right side of the motion. This is the right half, this is the left half kada. Yes. Your right half lo your acceleration to the left, speed to the left. Kani your left half lo your speed to the left and acceleration to the right. Ide kada. Ippudu you have to tell the which half it is, left half or right half. Chusko. Speed left, acceleration left. Speed left, acceleration left. Ante mean position nunchi right side kada. So it is the right side from mean position. Right of mean position, MP. Ide kada. Here I am talking about position. Chuskondi. Okay, sir. What if the speed is to the left, acceleration to the right? Ante speed to the left, acceleration to the right, mean position left side. Ante left of mean position. Ide kada. Yes. Left of mean position. What if, sir, speed is to the right and acceleration is also to the right? Ante speed and acceleration, they are in the same. Chusko. Speed to the right, acceleration to the right, and left of the mean position. And idi kuda left of mean position. And lastly, cheppandi andariki. Lastly, what we can say is, let me just zoom it out. Something like this. Look, cheppandi. Ante last case lo me speed right lo unte acceleration left lo undali. Which case ra? Speed right, acceleration left. Speed right, acceleration left. Okay, speed right, acceleration left. Speed right, yeah. Rendu possibilities unnai. Okay, speed right, acceleration left. Speed right, acceleration left ante it is in the right side of the mean position. Ardhamaindi? Do you want me to discuss it once again? I will discuss it once again. Okay, choose one. Yes, very good. Right of the mean position. So the direction of speed, the direction of acceleration and position. What did I tell you? We had to observe these three things kada. Yes. Position, velocity, acceleration. Velocity, acceleration, position ante this is the table. Ide table. Velocity, acceleration, position. This is a table. If at all you have a good grip over this table, okay, if at all you have a good grip over this table, that means it will be very easy ra. Ante SHM becomes very easy for you, okay? SHM becomes very easy for you. Ippudu chudandi, okay? Now I want you to focus only on this table. Jagrata andariki, okay? I only want you to focus on this table, okay? Which table, sir? This table. This table, okay? This part. I want you to imagine only this part of the motion. Do you find some interesting observation, Ra? Do you find some interesting observation? Choose. Do you find some interesting observation? In this case, I'm not talking about velocity, acceleration and position. Are you finding something special, Ra? What special, sir? Position right side lo unte, your position is right, acceleration is in the left. Position left lo unte, acceleration in the right. Ekkada kuda position left lo unte acceleration in the right and position right lo unte acceleration to the left. Ante your acceleration is always opposite to position. Ardhamaindi kada? Yes. Your acceleration is always opposite to position. Ante చూసుకోండి, we are taking everything on x and y axis now, okay? ఇదే నా x axis. Ante this point, let us say it is x is equals to 0 ra. Okay, mean point. Na mean point. Ide na mean point. Okay, ante origin. This is my extreme point. Let us say x is equals to some random value istunnara. Chuskondi. What random value should I take? Let us say some maximum value ante a. 1, 2, 3, 4, 5, 6 ante a. Some random value. Okay, right. Ekkada kuda ippudu if this is origin, right side is plus x axis, left side becomes minus x-axis kada. Yes, so points plot చేస్తున్నాం, so it becomes x is equals to minus a automatically. చూసుకోండి. So this is a framework ra, okay? This is a framework in which we will be talking. ఇదే నా mean point, ఇదే నా first extreme point, లేదా you can simply say it is left extreme, okay? ఇదే నా left extreme point and that becomes my right extreme. X is equals to a kada. Yes, so sir, x is equals to a ante that becomes my right extreme. ఇప్పుడు చెప్పండి, what did I say ra? What did I say? ఈ మొత్తం points కోసం you can simply say that the value of x is greater than 0. ఇదే కదా, చూసుకోండి రా, x is greater than 0 అంటే ఏంటి? రైట్ సైడ్ ఆఫ్ ద పాజిటివ్ x axis కదా. yes, so ఈ మొత్తం వాల్యూస్ కోసమే you can simply say the value of x is greater than 0 and ఈ పాయింట్స్ కోసం you can say x is less than 0. ఇదే కదా. yes. Just change the color now. Okay, for these points the value of x is less than 0. Okay, sir, what if the value of x is greater than 0 and less than 0? ఇప్పుడు acceleration గురించి మాట్లాడాలి. Okay, tell me about the acceleration ra. If your displacement to the right side, acceleration to the left side అంటే opposite of displacement కదా. yes, so if మీ acceleration positive ఉంటే, sorry, displacement positive అంటే position positive right side లో ఉంటే మీ acceleration must be negative. ఇక్కడ కూడా your x is less than 0 అంటే acceleration should be positive. Are you understanding? yes, it's reverse. It's reverse. Reverse అంటే values కూడా reverse వస్తుంది. అదే కదా, x is plus 2, acceleration becomes minus something, not minus 2 exactly, not minus 2. You don't understand, sir. If x is equals to 4, acceleration is minus 4. ఇదే కదా. no, we are not talking about values, we are only talking about directions ra. అంటే x కి వాల్యూ పాజిటివ్ ఉంటే యాక్సిలరేషన్ కి వాల్యూ నెగటివ్ వస్తుంది. అదే, this is only that we have discussed till this point ra. అర్థమైంది కదా. yes, you understand there is a little twist in the concept. They are not opposite, they are reverse. Reverse ante telsa, reverse ante opposite in directions, not in values. Ippudu I just did not talk about value at all. Understanding? Okay, so there was this observation. What was the observation ra? Sir, acceleration is coming negative of the position. Ade ide kada. yes, ante enti ra, chuskondi. Acceleration is directly proportional to negative of x. This was the result. For now I would just tell you this is a result. Kani, this is not how the equation of SHM is derived. We need the differential equation first. Our differential equation ni solve chesina tarvata we get this relation ra. Acceleration ante enti sir? Displacement, you differentiate the displacement, meeku speed vastundi. Speed ni malli okkasari differentiate cheste acceleration vastundi kada. So you can simply say, sir, acceleration is equals to double derivative of displacement with respect to time. ఇదే కదా. yes, so you can simply say, sir, d squared x divided by dt squared is directly proportional to negative of x. Negative of x అంటే direction is opposite. అదే, you are understanding? You are understanding? good, very good. so ఇదే మీ ఈక్వేషన్ ఆఫ్ SHM లేదా this is a representation of your SHM. SHM లో గుర్తుపెట్టుకోండి, for always you remember acceleration is opposite to the displacement. అంతే కదా, and it is directly proportional also. అంటే this is the equation ra. okay, this is the equation. This is in the differential form. You don't have to solve it. okay, the physicists, they discovered this equation. ఈ equation discover చేసిన తర్వాత they handed it over to the mathematicians ra. mathematicians. now ఇప్పుడు a mathematician solves this equation and gives you the solution. సొల్యూషన్ గురించి కూడా మాట్లాడుతాం, కానీ ఫస్ట్ విల్ టాక్ అబౌట్ ద ప్రపోర్షనాలిటీ రా. చూసుకోండి, ఇన్ SHM ఏదైనా SHM ఉంటే, ఇన్ ఎనీ SHM what do we say, sir? We can simply say in any SHM acceleration is directly proportional to negative of x. ఇదే కదా. ఇప్పుడు what we do is we replace this directly proportionality symbol, with a constant ra. అంటే తెలుసా కదా. yes, so sir, acceleration is minus k into x లేదా k into minus x. I just taken that sign outside ra. చూసుకోండి, k into minus x. ఇదే కదా. yes, ఇప్పటి కోసం, because I am telling you, for now you understand, for now, okay, for now you understand this value of k is something special value ra. We will say acceleration is equals to minus omega squared x. కానీ ఓన్లీ ద థింగ్ దట్ ఐఎమ్ డూయింగ్ ఈజ్ ఈ కేని వాల్యూ మార్చేస్తున్నారు, చూసుకోండి. ఐఎమ్ జస్ట్ చేంజింగ్ ద వాల్యూ ఆఫ్ కే టు ఒమేగా స్క్వేర్. ఓకే, అదే wherever you see the equation something like this, close your eyes and say that this is the equation of a simple harmonic motion. అదే అర్థమైంది అందరికీ? yes, a is equals to minus omega squared x లేదా a is equals to minus k into x. k అంటే ఏదైనా వాల్యూ it could be, okay. a is equals to minus 2x minus e to the power x, not minus e to the power x, sorry. a is equals to minus 2 into x లేదా a is equals to minus e into x, not e to the power x కదా, where a is a constant number and x is also a constant number. అంతే కదా? yes, where a is a constant number, where a is a constant number and x is a variable. ఇదే కదా? yes, so a is a constant number and x is a variable. అంటే ఇక్కడ నుంచి a is equals to e into x, that means you get the value of x is equals to a by e. అదే కదా? so this is the equation that we solved. Okay, and all of you, you cannot understand that no, it's not a constant number, it is the motion. ఈ motion లో a is not a constant number, a is the acceleration. Okay, a is acceleration and x is not a variable, x is the position. Okay, x is the position of the particle. వినండి, these are the things, don't get confused. Okay, ఎక్కడైనా whenever you are getting the acceleration as a function of displacement, kinematics 1D గుర్తుందా? acceleration as a displacement of, acceleration as a function of displacement, what we do is we say that it is a simple harmonic motion. Question తీసుకోండి ఒకసారి. if the acceleration of a particle is given by a is equals to 4 into x equals to is it a simple harmonic? So I deliberately confused you. Okay, yeah, I did confuse, yes, absolutely. And you must be strong kada, your foundation should be good, right? I'm confusing you, you will get confused. yes, okay, is it SHM or not SHM ra? ఈ కండిషన్ అంటే SHM condition or not SHM condition? Okay, SHM condition, right. So according to most of the students, it is in SHM. చూద్దాం. Let us do the analysis, okay? Analysis అంటే ఏంటి? Let us say initially, let us change the values of x. అంటే ఏంటి రా? SHM ఉంటే it must have some mean position కదా? yes. So let us say ఈ mean position లో x is equals to 0. Here x is equals to minus a. Here x is equals to plus a. ఇదే కదా? yes. Let us take values also, okay? Values. plus a అంటే let us say x is equals to plus 4 meter. I am just assuming, okay, assume చేస్తున్నారు చూసుకోండి రా. Okay, SHM condition, SHM condition, SHM condition. Okay, chat box, confirm SHM condition. Very good, very good, very good. So it should be minus 4, okay? Let us say x is equals to plus 4 meters, x is equals to minus 4 meters. జాగ్రత్తగా వినండి. If the motion is SHM, what can you say, sir? SHM ఉంటే it should go to the right, కానీ at the top extreme position it should stop రా. And దాని తర్వాత it should come back కదా. Yes, speeds గురించి చెప్పండి. So sir, if your acceleration is 4 into x, చెప్పండి. ఈ పాయింట్లో ఇనిషియల్ point అంటే ఏం పాయింట్ రా? ఈ పాయింట్లో చూసుకోండి. A is equals to 4 into x కదా. 4 into 0 అంటే 0 meter per second square. This is your acceleration. అంతే కదా. సో ఇదే నా acceleration కి వాల్యూ వచ్చింది at the mean point. ఈ mean point తర్వాత let us say the particle is moving to the right side రా. చెప్పండి x is equals to 1, somewhere 2, somewhere 3, somewhere 4. Here 4 into x అంటే 4 into 1 becomes a is equals to 4. ఈ కేసులో acceleration is 8. ఈ కేసులో acceleration is 12. And here acceleration is equals to 16. ఇదే కదా. చెప్పండి. రైట్ 4 into x రా. 4 into x అంటే 4 into 1 4 into 2 8 4 into 3 12 4 into 4 16 meter per second square. Okay? Acceleration is positive. Values చూసుకోండి. Positive acceleration ఉంటే speed should increase. అదే కదా. Yes. So after some time, let us say speed is v is equals to u plus at కదా. Yes. v is equals to u plus at. So let us say after 1 second, 2 సెకండ్ తర్వాత 3 సెకండ్ తర్వాత 4 సెకండ్ తర్వాత చెప్పండి స్పీడ్స్ కి వాల్యూస్ చెప్పండి సార్. v is equals to u plus at. u వాల్యూ 0 ఉంటుంది కదా. yes, started from rest. let us imagine ఒక సెకండ్ తర్వాత the speed becomes 4 meter per second. 2 సెకండ్స్ తర్వాత speed is 8 meter per second. 3 సెకండ్ తర్వాత speed is 12 meter per second. 4 సెకండ్స్ తర్వాత it is 16 meter per second. చెప్పండి, is the speed is increasing or decreasing రా? Increasing. So speed continuously increase అయితే do you think there will come a time at which the speed becomes 0? No? Do you think there will come a time at which the speed becomes 0? No sir, it will continuously increase. 4 8 12 16, it will keep on going to the right side ra. It can never come back. Understanding? It can never come back. 8, yes, 12 16 20 24 28, 32, 36, 40, 44, 48, 52, all the case speed keeps on increasing. And if the speed is increasing, the distance also increases. And do you think it will come back again ra? Kani SHM unte the particle should move back and forth kada. It is not coming back at all. Understanding? Yes. So that means the speed is continuously increasing, sir. Speed continuously increase aithe the particle keeps on going to the right side. Ardhamaindi? Are you understanding? Yes. Until it will not come back. Ade, what would happen if the same acceleration was negative? Acceleration negative unte your speed decreases. Koncham samayam tarvata speed becomes 0. And if the speed is 0, it will come back again. అంటే చెప్పండి, now is it SHM? Is it SHM రా? Is it simple harmonic motion? Yes. No, it is not simple harmonic motion, not a SHM. Enduku sir, it looks like a is equals to omega squared x kada. A is equals to omega squared x. Can you forgot a little thing? Okay, chinna topic ra. There is a small thing that is sine ra. It is not SHM. A is equals to minus omega squared x is an SHM. Chuskondi. Did I give you A is equals to minus 4x ra? A is equals to minus 4x unte it is SHM. No doubt in it. For sure, 100% your omega is going to be 2. కానీ ఈ కేసులో your acceleration is not opposite of the displacement. అంటే యాక్సలరేషన్ డిస్ప్లేస్మెంట్ ని సపోర్ట్ చేస్తున్నారా ఈ కేసులో? అంటే the acceleration is never going to decrease the speed. అంటే there is never going to be an extreme point. అంటే the particle is never going to come back. అదే కదా? Yes. Very good. సో ఇప్పుడు what is the correct version, sir? జాగ్రత్తగా వినండి. even a single negative or positive sign can cost you 4 marks in your examinations. Ardhamaindi? Okay, perfect. Yes, 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 there is no minus sign. Yeah, in the question, if it asks minus a is equals to 4x, is it SHM ra? Is it SHM or not SHM? Cheppandi. Minus a is equals to 4x, a is equals to minus 4x. Sir, minus a is equals to minus 4x and a is equals to 4x. Which is SHM, which is not SHM? Cheppandi. Question number 1, number 2, number 3, number 4. Which is SHM, sir, and which is not SHM? Only this is SHM. Ade kada? Only number 2 is SHM. What about 1, sir? Sir, it is also SHM. Choose. This negative sign is there. You can send it that side, right? Yes, both are same. Both are same. These are not SHMs. Choose. These two are not SHMs. There is no negative sign. Negative cancel end low, it becomes plus 4x only. Simple maths kada? Yes. Good. 1 and 2 are SHMs. Okay? Perfect. So, what is the equation of SHM, sir? Sir, SHM lo particle should move in back and forth position and the acceleration of the particle should be related to its position. Same equation, equation should be A is equals to minus k into x లేదా minus omega squared into x. Choose. The best example will be A is equals to minus 4x లేదా A is equals to minus 6x. Whatever you want to take, okay? So A ante acceleration, x ante position of the particle. Choose. A is acceleration, x ante position. Acceleration ante entira, okay? Right. So this is the equation of simple harmonic motion. Choose. Kani, equation lo, what did we say? Some acceleration should be equals to negative k into x. Something constant ra. Proportionality constant kada. What did I say then? E k rasina tarvata, I told you that I am changing this k with this omega squared. Omega squared ante enti telusara? Omega squared ante enti? Ippudu omega has a special significance. What is the special significance? Andariki jagrataga vinandi, okay? Omega ante it has a special significance. So ee omega ni ardham cheyadaniki we talk something about your simple harmonic motion as a function of leda SHM, simple harmonic motion as projection of circular motion. Idi chala important. This is one of the most important concepts you will ever see in your SHM. Projection of circular motion. Andariki jagrataga vinandi, because if it's not clear, then you will face a lot of the problem. Okay? I did not write minus a. Where is it? It's not minus a. It's simply a kada. If the acceleration of a particle is given by this, it's not minus a, it's off. చూసుకో అంటే ఏంటి రా ఇప్పుడు జాగ్రత్తగా వినండి ఓకే now let us say this is my circular motion అందరికి let us say this is my circular motion okay అంటే ఈ circular motion లో you can say I have two different lines ఇది నా first line, this is my second line of observation okay. Too closer. Something is wrong, Ray. I'm not understanding what's wrong. Something is for sure wrong, okay? Something like this. Observation. Choose. So if at all I have a particle, okay? Then a particle, choose. And this particle is initially on this line. Initially on this line, okay? Initially at this point, okay? Now the goal is that this particle is moving uniformly over the circle, okay? The particle is moving uniformly over the circle. కానీ నాకు projections కావాలి. Projections అంటే ఏంటి సార్? You do one thing, you take a big torch, okay? ఇదే నా torch రా, okay? There are lights falling on this torch, something like this. అర్థమైంది? Can you tell me where is the shadow of this particle రా? Shadow చెప్పండి. Where do you think will be the shadow of that particle? Sir, the shadow will be right below. అంటే this is the shadow. అంతే కదా? That becomes the shadow of the particle. This over here becomes the shadow of the particle. అందరికి అర్థమైంది? Okay. What if the particle comes at this point, sir? కొంచెం సమయం తర్వాత it has moved and it had come to that point. ఇప్పుడు shadow గురించి చెప్పండి అందరికి. Where is the shadow? Shadow looks something like this, sir. అర్థమైంది అందరికి? Okay. What if the particle is coming at this point? Here. What if it's coming this point? And what if it's coming this point? చెప్పండి. What if it's coming this point? At this point, at this point, at this point. It is moving in a circular motion kada? So something like this. చెప్పండి. At each and every single point నాకు shadows కావాలి రా. చెప్పు. So ఈ point లో the shadow looks something like this. On this point the shadow is like this. On this point the shadow is like this. ఇదే కదా? So these are my shadow points అందరికి. అర్థమైంది? So these are the shadow points. Here the shadow looks something like this. Now it is going to the left kada? So the shadow also moves to the left. Left. Okasari the particle has crossed this position, ante this position. Here, then it comes here. Ekkada, then here. Pardamadi. Ippudu cheppandi shadows gurinchi sir. So the shadows will look something like this. So here is the shadow, here is the shadow, here is the shadow, here is the shadow, here is the shadow. Ekkada. And here comes back to the right, comes back to the right, comes back to the right. అర్థమైంది? అంటే now you try to understand all of it. You try to understand when the particle was actually moving on this circle like this ra, this is a motion of the particle kada? Yes. What about the shadow motion ra? చెప్పండి. The motion of the shadow was looking something like this. So sir, the particle is moving like this. అంటే the shadow is moving something like this. ఏమైందిరా? Yeah, try to understand, okay? Hey, how did it come? Okay, choose one. So the particle is moving something like this, the shadow is moving something like this. Understanding? It's too difficult to tell you. Okay, something like this. Choose one. When the particle is moving like this, the shadow moves and back and forth. Are you understanding? Shadow moves back and forth. అర్థమైంది కదా? ఇక్కడ కూడా the same thing around y axis also. This is my horizontal projection. ఇదేనా horizontal projection. What about the vertical projection, sir? Vertical projection లో కూడా same thing రా. You drop the vertical perpendiculars. అదే. Instead of horizontal, you drop vertical perpendiculars. అంతే కదా? When the particle was here, shadow was here. Particle was here. ఇక్కడ కూడా చూడండి. These are the shadow points kada? Yes. And then, when the particle is moving like this, the shadow moves like this. Are you understanding? So it has two different projections. Vertical projection లేదా horizontal projection. Just అంటే ఏంటిరా అంటే ఐఎమ్ రైటింగ్ అ స్టేట్మెంట్ నౌ. You try to understand, okay, the meaning and the translation of it. Statement is when a particle moves in a circle, when a particle moves in a circle, its projection along any line, not only horizontal, not only vertical రా, ఏదైనా లైన్ తీసుకోవచ్చు. ఇదే నా సర్కిల్ ఉంటే you can take some random line also. Particle is moving something like this, shadow performing SHM something like this. లేదంటే you can take this line also. Particle moving something like this, shadow performs SHM something like this రా. మీరు ఏదైనా లైన్ తీసుకోవచ్చు. ఓకే, yes, particle circular motion లో ఉంటే shadow performs simple harmonic motion. Okay, along any line performs simple harmonic motion. అంతే కదా? అర్థమైంది. సో ఇప్పుడు what I am talking about is your circular motion. చూసుకోండి, ఇదే మీ సర్క్యులర్ మోషన్ కదా. ఎస్, సో లెట్ us talk in terms of some terminologies రా. దిస్ ఈస్ ద సెంటర్ ఆఫ్ ద సర్క్యులర్ మోషన్. చూసుకోండి, ఇదే సెంటర్ ఉంటే యూ డ్రా ద ఎక్స్ యాక్సిస్, యూ డ్రా వై యాక్సిస్. అందరికి ఇదే నా పార్టికల్ రా. ఓకే, let us say this particle is at this point now and moving with some angular speed. Circular motion లో angular speed ఉంటుంది కదా. ఎస్, సర్క్యులర్ మోషన్ లో there is always an angular speed omega. జాగ్రత్తగా వినండి. ఒమేగా 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 సార్, ఒమేగా 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 అంటే వేర్ ఇస్ ఒమేగా? ఒమేగా సార్, ఒమేగా. దిస్ ఒమేగా ఈజ్ సేమ్ యాజ్ దిస్ ఒమేగా అంటే తెలుసా? అంటే ఏంటిరా చెప్పండి. సో నౌ లెట్ us try to write the general equation of the simple harmonic motion. అంటే ఏంటిరా? You try to understand. If I give you a question, sir, ఈ question లో acceleration is -16 into x. అంటే ఏంటి సార్? acceleration should be minus omega square into x. ఈ ఫార్మ్ గుర్తుపెట్టుకోండి అందరికి. ఓకే, you compare omega square value, మీకు 16 వస్తుంది. ఇక్కడ నుంచి you can simply say, sir, omega is equals to 4. యూనిట్ ఏంటిరా? omega unit of omega is radian per second. అంటే ఏంటిరా? నౌ ఐఎమ్ ట్రయింగ్ టు కమ్ టు ద మెయిన్ కన్క్లూజన్. చూసుకోండి, అంటే దిస్ ఈజ్ యువర్ సింపుల్ హార్మోనిక్ మోషన్, నో డౌట్ ఇన్ ఇట్. ఈ సింపుల్ హార్మోనిక్ మోషన్ అంటే దిస్ ఈజ్ అ బ్యాక్ అండ్ ఫోర్త్ మోషన్ కదా. ఎస్, పార్టికల్ ఈజ్ మూవింగ్ బ్యాక్ అండ్ ఫోర్త్ సంథింగ్ లైక్ దిస్. మరి సార్, వై వీఆర్ టాకింగ్ అబౌట్ ఒమేగా? ఒమేగా ఈజ్ ద యాంగులర్ స్పీడ్ ఆఫ్ ద యాక్చువల్ రొటేషన్ మోషన్ రా. చూసుకోండి, దిస్ ఈజ్ అ ప్రొజెక్షన్ ఓన్లీ. But the actual circular motion, whatever is happening ra, ఈ particle లో omega is equals to 4 radian per second. అంటే ఒక్క సెకండ్ లో the particle is covering 4 radian of angular displacement. అంతే కదా? yes, very good. So the particle, although it is in SHM ra, ఇప్పుడు we will not see SHM as only SHM. We will see SHM as a projection of a circular motion. ఎక్కడి నుంచి గుర్తుపెట్టుకోండి మైండ్ లో. here onwards we will see what we will see ra. Here onwards we will see SHM, simple harmonic motion, as projection of circular motion. అంతే కదా? So here onwards ఎప్పుడైనా మీ SHM ఉంటే you will see this SHM is nothing but projection of circular motion. Projection అంటే shadow. So ఈ shadow నుంచి you will have to jump at the original person. Usually what happens is you see the person, then you see the shadow రా. కానీ ఇక్కడ we have to emphasize a little on your memories and you have to go backwards. అంటే SHM ఉంటే circular motion visualize చేయండి. అదే, are you able to understand? Very good. అందరికి all of you, very good. చూసుకోండి. Sir, so now that we have explicitly entered into simple harmonic motion, ఇప్పుడు let us talk some things about simple harmonic circular motion. ఎందుకంటే our circular motion chapter has been completed. And akkada మా దగ్గర some formulas ఉంటుంది. ఆ formulas అంటే they'll help us directly into this formula also. చూసుకో. Okay? So particle is starting from the mean position రా. ఈ mean position నుంచి extreme position పై and అక్కడ నుంచి కూడా coming back to the mean position and then moving to the left extreme position, then moving back to the mean position. అంటే one complete motion లేదా one complete cycle కదా. చూసుకో. Started from this point, moved to the extreme point, then coming back to the original mean point, then again coming back to the left point, and then moving to the own position. Ante ide now complete one cycle of SHM. Ade kada? Yes. So what is the time for this total one cycle? How much time it requires to perform one complete cycle? Sir, I don't know. Naku telide. Kani we have just mentioned that SHM ante it is a projection of circular motion. Kani circular motion lo na daggara formula untundira about that time of rotation. Cheppandi, what is the formula for a time period of rotation in a circular motion, sir? So if this is my SHM, this over here should be the correct, not correct. ఓకే, అర్థమైంది. అర్థం చేసుకోండి అందరికి. ఓకే, ట్రై టు అండర్స్టాండ్ ఆల్ ఆఫ్. ఓకే, అంటే mean position అంటే the central position. That means the particle is either here లేదా it is here. అదే కదా the projection will only go to the mean position. Shadow. The particle should be here లేదా it should be at the bottommost point. Right? Yes, very good Gunat, very good. And if the particle is moving in a circular motion, చెప్పండి, your time period of motion, total time, నా దగ్గర angular speed ఉంటుందిరా. Omega is the angular speed. We do have formulas, sir. Theta is equals to omega into t కదా. Uniform circular motion ఉంటే this is the formula. Distance is equals to speed into time formula రా. అదే what is the total cycle రా. It మొత్తం cycle కోసం what should be the value of theta, sir? Theta should be 2 pi is equals to omega into total time period kada, capital T. So ఇక్కడ నుంచి you can simply say, sir, T is equals to 2 pi by omega. అంటే ఏంటిరా, ఇప్పుడు చూడండి all of you, when the particle is starting from this point, వినండి, it is moving entire circle and coming back to the same point. ఈ మొత్తం రొటేషన్ చేయడానికి what the time is 2 pi by omega. ఇప్పుడు ప్రొజెక్షన్ గురించి చెప్పండి. when the particle was here, the projection was here కదా. when the particle is moving at this extreme point, the projection also moved at this extreme point రా. ఎక్కడ నుంచి particle coming back to the same position, అంటే ఎక్కడ నుంచి particle coming back to the same position, here onwards particle moving to the left రా. first time చూసుకోండి, particle moving to the left first time extreme position, దాని తర్వాత again particle coming to the right, దాని తర్వాత again particle coming to the right, అంటే coming back to the original position, time period will be the same. Okay, time period remains the same. అంటే ఈ మోషన్ కోసం కూడా your time period t is equals to 2 pi by omega. omega అంటే ఏంటి సార్? omega is the angular speed. ఎలా ఫైండ్ చేయాలి సార్? it will be given to you in your questions. అంతే కదా? yes. సో ఇప్పుడు ఒక క్వశ్చన్ రాసుకోండిరా. సో your question is, Perfect, 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 perfect. Acceleration is minus 16 into x. Compare చేసుకోండి. A is equals to minus omega square x తోనే. What you will get is, చెప్పండి, omega square is 16, omega is 4. That means your time period is 2 pi by omega. ఇదే కదా? అంటే 2 pi by 16. Seconds units కూడా రాసుకోండి. These are pi by 2 seconds. అంటే ఏంటిరా? Once you are given the question, answer వచ్చిందంటే your question is not end. Okay? మీకు విజువలైజ్ చేయాలి. How to visualize? What to visualize? చూసుకోండి. If your particle is starting from some random position, right? It's in SHM కదా, question లో ఇచ్చారు, already given is the question, రా చూసుకోండి. So ఇదే నా extreme point, ఇదే నా extreme point, this is my mean point. ఇప్పుడు now I am telling you, it is not compulsory for the particle to start from the mean point, రా. ఏదైనా పాయింట్ మీకు కావాలంటే మీరు తీసుకోవచ్చు. ఆ పాయింట్ నుంచి start the motion of the simple harmonic particle, రా. చెప్పండి. So let us say particle starts from this point, లేదా this point, any general point తీసుకోవచ్చు. I'm starting from this point, రా చూసుకోండి. So starting from this point, something like this, and moving in simple harmonic motion. ఇదే కదా? Yes. అంటే ఏంటి సార్? If you are starting from this point, it has to cover certain ranges, రా. ఏం ranges, రా? First one is it has to move to the mean point. ఈ mean point నుంచి it has to move to the extreme point. దాని తర్వాత it will have to come again to the mean point. And దాని తర్వాత it will come again to the first extreme point, and ఇక్కడ నుంచి coming back to the original point. అంటే this is your first cycle. ఈ మొత్తం సైకిల్ కంప్లీట్ చేయడానికి వాట్ ఎవర్ టైం యూ హ్యావ్ రిక్వైర్డ్ ఇస్ 5 by 2 seconds. అర్థమైంది కదా? లేదా if you want to start the same motion from any standard point అంటే let us say at this point, రా. ఈ పాయింట్ నుంచి స్టార్ట్ చేసిన తర్వాత పార్టికల్ మూవ్స్ టు ద రైట్, దాని తర్వాత మళ్ళీ ఒకసారి రైట్, దాని తర్వాత టు ద లెఫ్ట్ అండ్ అగైన్ టు ద లెఫ్ట్, అంటే టోటల్ సైకిల్ కంప్లీట్ అయింది. ఈ మోషన్ కూడా ద సేమ్ టైమ్ ఇస్ రిక్వైర్డ్, అంటే 5 by 2 seconds. అర్థమైంది కదా? యూ మస్ట్ బి అండర్స్టాండ్. You must be understanding all of it. చూసుకోండి. Next. So now that we talked about omega, we also talked about your acceleration, your displacement, your position. ఎప్పుడు let us talk something about circular motion only, రే. చూసుకోండి. ఇదే కదా? Yes. అందరికి. So this is my center of the circle కదా? Sir, simple harmonic motion లో you are talking us about circular motion. Yes, physics అంటే ఇదేరా. there are a lot of similarities in physics. చాలా similarities ఉన్నాయి, చూసుకోండి. So let us try to plot the equation of SHM. ఇప్పుడు నేను ఈక్వేషన్ గురించి మాట్లాడుతున్నాను అందరికి, చూసుకోండి. ఓకే, the title is equation of simple harmonic motion. ఈక్వేషన్ అంటే ఏంటిరా? ప్రొజెక్షన్ కదా. ఈక్వేషన్ అంటే ఏంటి సార్? Is it not the equation? Is it not the equation? Yes, it is the equation. కానీ this equation is telling you the relationship. చూసుకోరా. Why do we write the equations, రే? Why do we write the equations? So if I say, sir, y is equals to x squared. What is the significance of this equation, రా? ఈ ఈక్వేషన్ నుంచి you understand the relationship between the two terminologies. అంటే two entities, రా. ఇదే అంటే y, ఇదంటే x. What is the relationship between these two is expressed by this equation. అర్థమైంది కదా? Equation always tells you the relationship between the entities. ఇక్కడ చూడండి, what are the entities, sir? ఇదే అంటే నా acceleration and this is my position. అర్థమైంది? So SHM లో what is the relationship between acceleration and position అంటే this. You don't have to see any other equation. ఇదే మీ simplest, easiest and the biggest equation for your acceleration and the displacement. కానీ we don't have acceleration and the displacement కదా, we have speed kuda, we also have time, we have acceleration, we have displacement అంటే x. ఇదే కదా? Yes. So we talked about acceleration and displacement. కానీ what about acceleration and time? Sorry, displacement and time, speed and time, acceleration and displacement, speed and displacement, all these relationships we have to understand. Okay, అంటే మీకు random అంటే వేరే ఈక్వేషన్స్ చదవాలి. Understanding? Yes. So ఇప్పుడు we will talk about the equation that links your displacement x with లేదా versus, versus అంటే with only, your displacement as a function of time రా. నాకు displacement as a function of time కావాలి. How will you do it? That is the question. Okay? How will you do it? అంటే the displacement in SHM as a function of time. To understand that, all of you. Yes. To understand that, we will have to see some other aspects. Choose. So if you are saying that this is your y-axis, let us say the particle is here. Here ante enti ra? Now I want to talk about the projection kada. Yes, projections kavali, projections. What did I say? You can take the projection of a circular motion along. Where did I write? You can take the projection of a circular motion along any line kada. Where did we write it? Is it gone or what? Yeah, it's projection along any line kada. Any line unte it could be your x-axis also. లేదా it could be your y-axis. X-axis, y-axis ante horizontal projection, vertical projection. Okay, understand. Don't say sir this is x-axis, this is not. Idante horizontal projection. This in the sense your vertical projection. Other than these, you can take any line. Meeku ఏదైనా line కావాలంటే తీసుకోవచ్చు. You can take the projection along each and every line. It will be a simple harmonic motion. అర్థమైంది అందరికీ? Right. So here let us talk about your horizontal and vertical projection రా. సో ఇప్పుడు మొదటిగా నేను హారిజంటల్ ప్రొజెక్షన్ గురించి మాట్లాడుతున్నాను, చూసుకోండి అందరికి. సో దిస్ ఈజ్ యువర్ హారిజంటల్ ప్రొజెక్షన్. అంటే యువర్ ప్రొజెక్షన్ అలాంగ్ దిస్ లైన్ ఈజ్ ఈక్వల్స్ టు యువర్ ప్రొజెక్షన్ అలాంగ్ దిస్ లైన్. అంతే కదా. డిస్ప్లేస్మెంట్ చూసుకోరా. ఇఫ్ ఇట్ ఇస్ x, if it is -x, -x. Understanding? అదే. So that means your projection along this line is nothing but your projection along this line. అర్థమైంది అందరికి? How to change it, right? How to change it? I can't change it, right? Yes. I can't rotate it. The biggest problem is this. Choose. Okay. That means your this line projection. ఇదే కదా. Your projection along this line is equals to your projection along this line. అర్థమైంది అందరికి? ఎస్. ఇప్పుడు నాకు ఈ లైన్ పైన ప్రొజెక్షన్ కావాలంటే you say after some time రా, కొంచెం సమయం తర్వాత, let us say t seconds have been passed. Okay, t seconds have been passed and the particle has come to this position. చూసుకోండి. యాంగులర్ స్పీడ్ అంటే ఒమేగా. అందరికి అర్థమైంది కదా. యాంగులర్ స్పీడ్ ఒమేగా తోనే t seconds తర్వాత the particle has come to this point. అంటే యాంగిల్ చెప్పండి. యాంగిల్ అంటే ఏంటిరా? This is the angle theta that it has covered. అందరికి. What is the angle? Theta. What should be the formula for theta, sir, in circular motion? Circular motion lo, what should be the value for theta ra? Theta. What should be the value for theta, sir? Sir, theta ante displacement, it should be omega into t. Ide kada. So ee theta is equals to omega into t. Ade. నాకు ఏం కావాలంటే I only want the projection అనేది తెలుసా? This is my mean point x is equals to 0 రా. ఈ mean point నుంచి t సమయం తర్వాత where did the particle projection has moved? Where did the particle projection has moved రా? చెప్పండి. సో the projection is somewhere here కదా. ఎక్కడ? This distance. నాకు ఈ distance కావాలి. అదే. సో sir, if this angle is theta, ఈ angle theta ఉంటే చెప్పండి అందరికి. What will you say, sir? This angle becomes 90 minus theta kada? Yes. And what about the radius ra? Radius of the circular motion, sir, let us say it is r. Andariki. Triangle. Are you able to see a triangle andariki? Are you able to observe a triangle? Triangle ante em triangle, sir? So this is a triangle. Chuskondi. Are you able to observe a triangle, all of you? This. It is a triangle. Can you see it? Yes. Not resolve. Yeah. You can resolve also. Kani ee triangle lo values చెప్పండి రా. If it is 90 minus theta, can you say this is also theta రా? అందరికి I have different ways. Can I am assuming this way. ఇది కూడా theta కదా? Yes. Length is r, angle is theta. Sin theta చెప్పండి సార్. Sin theta is equals to opposite side by hypotenuse. ఇదే కదా. Sin theta అంటే opposite side ఏంటి రా? ఇదే మొత్తం x. Sin theta is x divided by hypotenuse అంటే ఏంటి? ఇదే 90 degree, hypotenuse is r. అంటే x వాల్యూ వచ్చింది నాకు. X వాల్యూ is r into sin theta. ఇదే కదా. థీటా అంటే ఏంటి సార్? theta is simply equals to omega into t ante x is equals to r into sine of omega into t ide. So this is your relation of distance x versus time t ra. X and time t వచ్చింది కదా, అర్థమైంది అందరికి? yes. So ante your displacement in SHM is given as x is equals to r into sine of omega into t. Kani what is r sir? What is r? R ante radius kada, చూసుకో. R is the radius ra. Okay sir, what about the amplitude conditions? Amplitude conditions గురించి చెప్పండి రా. ఇదేనా x is equals to 0 point కదా. Amplitude ante the particles should move maximum to the right ra. What is the maximum distance to the right side? చూసుకో. ఇదంటే రేడియస్. రేడియస్ అంటే మీ maximum amplitude అంటే a. ఇదే కదా. Yes, a is radius only. Ante you can replace this radius with your maximum amplitude a. X is equals to a sine omega t. So this is your equation of SHM. But the equation lo there is a link with displacement and time. Ardhamaindi kada? Yes. Very good. Very good. Very good. So sir, if this is your SHM, kani చూసుకోండి రా, there is a little twist. I want you to focus. Where did the particle start from ra? ఇక్కడ నుంచి కదా. Here. It started from at this point. ఈ పాయింట్ అంటే ప్రొజెక్షన్ చెప్పురా. Projection ante exactly from the mean point. Ante if the particle is starting from the mean point, then we say mottam scenario is valid. Ante this equation is valid if and only if, చెప్పండి కదా, if and only if the particle starts, if and only if the particle starts from the చెప్పరా mean point. If the particle is not starting from the mean position, this formula doesn't hold good. అంటే ఈ ఫార్ములాలో we will have to add some correction terms ra. We will do it later on. కానీ ఇదే the equation of the position కదా. yes, చూసుకోండి. పొజిషన్ అంటే డిస్ప్లేస్మెంట్. పొజిషన్ అంటే డిస్ప్లేస్మెంట్ కదా. yes, పొజిషన్ అంటే డిస్ప్లేస్మెంట్. అందరికి పొజిషన్ అంటే డిస్ప్లేస్మెంట్. Do you think are you able to think any formula related to displacement and speed ra? Any formula that relates displacement and speed? చెప్పండి. any formula that relates displacement and speed ra. sir, v is equals to ds by dt ఇదే కదా. kinematics 1D నుంచి రా. particle is moving in 1D only కదా, 1 dimension. kinematics 1D నుంచి గుర్తుపెట్టుకోండి. this is your speed formula రా. చెప్పు. so ఇక్కడ నుంచి what you can say sir, speed is equals to d by dt of displacement. displacement ఏంటి రా? a times of sine of omega into t. అర్థమైంది? differentiate చేసుకోండి. I am directly differentiated, it comes out to be a omega cos of omega t. okay, for those who did not understand, గుర్తుపెట్టుకోండి. this is the result. okay, this is a result. revision purpose. okay, so ide me speed in your SHM. okay, this is your speed in SHM, simple harmonic motion. andariki jagrataga gurtupettukondi. this formula idante చాలా important formula. okay, this is the formula for your speed in simple harmonic motion. ante enti ra? can we simplify it? yes, we can simplify it. చూసుకో. v is equals to sir just a minute. okay, what happened? okay, sir, v is equals to ఈ మొత్తం కదా, ఇవన్నిటి నుంచి you take this terminology as a special terminology, a cos of omega t. అంటే I can write this formula something like this also. చూసుకో. so I can simply say sir, v is equals to omega into a times of cos of omega t. ఇదే కదా. yes, class 10th lo you had a simple trigonometric formula, sin square theta plus cos square theta is 1 kada. sin square x plus cos square x is equals to 1. అంటే if you say sir, sin square omega t plus cos square omega t is equals to 1 kada. you multiply this equation with a square ra. a square, here also a square, and here also a square. ఇదే కదా. sir, here sign is positive, akkada pampandi. you simply say a square cos square omega t is equals to a square minus a square sin square omega into t. Ide kada? Yes. Take the square root, sir. So ikkada nunchi I can simply say a times of cos of omega t is equals to root of a square minus a square sin square omega into t. Sorry, omega into t kada. ఇప్పుడు చెప్పండి రా, ఏ సైన్ ఒమేగా టీ, ఏ సైన్ ఒమేగా టీ అంటే ఏంటిరా? ఏ సైన్ ఒమేగా టీ అంటే డిస్ప్లేస్మెంట్ కదా. సో ఇక్కడ నుంచి స్క్వేర్ ఇట్. సో సార్ ఎక్స్ స్క్వేర్ ఇస్ నథింగ్ బట్ ఏ స్క్వేర్ sin square omega t kada. Sin square omega t. You take this formula, you use it there, okay? You use it there and you can simply say, sir, a cos omega t ante enti ra? This. Chuskondi. This. Ekkada nunchi can I simply say, sir, a times of cos of omega t is equals to v upon omega. V by omega. Ade. V by omega. Ade. So ikkada nunchi you take this, substitute, a cos omega t is v upon omega is equals to root of a square minus x square. Ade. Ledante you can also simplify it like this. So you can simply say, sir, v upon omega is equals to root of a square minus x square kada. So ikkada nunchi you can simply say v is equals to omega into root of a square minus x square. Ade. This is also a very important result to remember. Okay? Andariki displacement time relation ochindi chusko. Till now whatever formulas we have discussed is this. The first formula that we discussed in SHM ante a should be equals to minus omega squared into x. ఈ ఫార్ములా ఇట్ ఈస్ లింకింగ్ యువర్ యాక్సిలరేషన్ విత్ యువర్ డిస్ప్లేస్మెంట్. అదే కదా. దాని తర్వాత వాట్ డిడ్ వి డిస్కస్డ్? ద నెక్స్ట్ ఫార్ములా వి డిస్కస్డ్ ఇస్ ఎక్స్ ఇస్ ఈక్వల్స్ టు ఏ టైమ్స్ ఆఫ్ సైన్ ఆఫ్ ఒమేగా టీ. ఇఫ్ దిస్ ఫార్ములా ఇట్ ఈస్ లింకింగ్ యువర్ పొజిషన్ విత్ రెస్పెక్ట్ టు టైం, రైట్? ఎస్. దాని తర్వాత వి టాక్డ్ అబౌట్ స్పీడ్ ఆల్సో. Talking about this formula, it relates your speed with time. Ante kada? Yes. Dan tarvata, we also said something like this. Formula number 1, idante formula number 2, this is your formula number 3. Formula number 3, andariki. Formula number 4, chuskondi. What did we say? V is equals to omega into root of a square minus x square. And this formula is actually connecting your speed with your position. Leda your position with your speed. Ante kada? Yes. So these were the basic formulas in your simple harmonic motion. Ardhamaindi? We can also talk about acceleration also. Cheppandi. So ippudu let us talk about some more terminologies ra. Chuskondi. So what did we discuss, sir? We told that speed is equals to a into omega into cos of omega into t. Ide kada? Yes. మళ్ళీ ఒకసారి డిఫరెన్షియేట్ చేసుకోండిరా. అంటే dv by dt షుడ్ బి ఈక్వల్స్ టు d by dt ఆఫ్ మొత్తం ఇవన్నిటిని. సో a ఇంటూ ఒమేగా ఇంటూ కాస్ ఆఫ్ ఒమేగా ఇంటూ t. ఇదే కదా. dv by dt is what, sir? Acceleration. dv by dt is acceleration. Sir, omega is there, take it out. So a omega constant, ఇక్కడ నుంచి omega it came out cos derivative of cos omega ra, cos theta is minus sin theta, ante it should be minus sin of omega t. Ide kada? Yes. So rewrite it ra, take this minus sign outside, okay, this negative side outside, and omega square I'm writing outside. What I'm left with is a times of sin of omega into t. But what is a sin omega t, sir? Sir, a sin omega t is displacement only, x. This is a proof that your acceleration is minus omega squared into x. Okay, so these are the formulas. What about your acceleration and your speed? And v is equals to omega into root of a squared minus x squared. Can I find the value of acceleration from this formula? Let us take a question andariki, okay? Hey, let us talk about cutoff in a separate video. Yes, a cutoffs gurinchi let us dedicate a separate session. Kani will not disturb our flow. So what is given, sir? The information that you have is starting from the mean position ante x is equals to 0 kada. X is equals to 0. Mari entira? Speed is 10 meter per second. Amplitude is 4 meters. Speed is 10 meter per second. And amplitude is 4 meters. Now it's all up to you what formula to use. M formula use cheyali. It is completely on your hands, okay? It is completely on your hands. And you can take, sir, P is equals to A into omega into cos of omega into T. Ledante, you can simply say V is equals to omega root of A square minus X square. Ide kada? If underneath you can substitute the value of t is equals to 0. Jagrataga vinandi, okay? When you substitute the value of t is equals to 0, leda your value of x is equals to 0. Both are the same kada. Starts from mean position ante starts from mean position. X is equals to 0, t is equals to 0. You can substitute directly and you can simply say, sir, v is equals to a into omega. Ante when you have a simple harmonic motion, ide me mean position x is equals to 0. This is your extreme position x is equals to a, x is equals to minus a. This situation unte, whatever be the case, the particle is crossing mean position and its speed must be equals to v times of a times of omega. Ade v is equals to a times of omega. Ardhamaindi kada? Okay? Yes. Even if you belong to whatever category, okay, your 450 marks, 450 to 470 minimum. If your score is below 450, okay, you can take whatever choice you are getting, but you will not get your dream choice for sure. Okay? Next, chuskondira. So me omega is equals to v is equals to a times omega kada. Yes, v given. Enta icharu sir question. V is equals to 10. A is equals to 4 into omega. Ante omega is equals to 5 by 2. Ide kada? Yes. 5 by 2 radian per second. Naku em kavalante naku time kavalira. Time ante enti sir? Once your omega has been calculated, ఇప్పుడు you visualize your SHM as a projection of a circular motion. లేదంటే మీకు formulas కూడా గుర్తుండే చాలా. You can directly tell the formula, sir. Total time t is equals to 2 pi by omega. ఇదే కదా? And there t is equals to 2 pi by omega value substitute చేసుకోండి. Omega value is 5 by 2. ఇదే కదా? So that means t is equals to 4 pi divided by 5 seconds. అదే. So that means what, sir? If let me take here only. Why to waste another page, sir? చూసుకో. That's sufficient. Right. Perfect. So, చూసుకోండి అందరికి. That means if your particle started from x is equals to 0. అంతే కదా? అర్థమైంది? Yes. It is the first time when it is crossing the mean position. Extreme point, first point. Second time ante it is coming to the most extreme position. Again, second time it is coming. That means one complete cycle has been crossed. Ardhamaindi? One complete cycle has been crossed. So for one complete cycle, how much time you require? Ante 4 pi by 5 seconds. That means after 4 pi by 5 seconds, this particle will be crossing the center 1 second. Okay? Yes. Correct. Yeah, second time only. It started from this point kada. First time. Second time. One complete cycle. Okay? One complete cycle. correct. So 4 pi by 5 seconds, not 2 pi by 5. Choose. So I think you have got the information about how to solve the things. Kani ippudu we will be dealing with some twists ra. Chuskondi. I can take this color. Not liking the colors. We're wasting our time, sir. Just ఇప్పుడు here it should be x is equals to a. ఇదే కదా. Now let us talk in terms of professional languages ra. Professional language ante enti ra? Professional language ante eppudu I am not going to have any mercy on you. Ante we will just talk everything about the simple harmonic motion. Formulas okasari formulas raskondi. Okay, త్వరగా I am writing this formulas. చూసుకోండి అందరికి. The first formula that I have is for your acceleration versus position. A is equals to minus omega squared. Hey, before this, దీనికి ముందు let us talk or let us write more formulas. Okay, fifth formula is your maximum speed. అందరికి చెప్పండి, your maximum speed is equals to A times of omega. గుర్తుపెట్టుకోండి, these are very important results. Okay, you cannot go continue back to the original questions, equations and find. లేదండి, you directly remember, గుర్తుపెట్టుకోండి, ఏమైనా SHM ఏదైనా SHM లో మీ మాక్సిమం స్పీడ్ ఫార్ములా అంటే A times omega. Omega అంటే ఏంటిరా? Omega is the angular speed with which the circular motion is happening. Sir, circular motion అంటే ఏంటి సార్? Yes, the same circular motion projection is your SHM. అర్థమైంది? A అంటే the amplitude. Yes, what about the maximum acceleration రా? Acceleration is minus omega squared x కదా. So maximum value ante x should be maximum. What is the maximum value of x ra? Amplitude. Ante me maximum value of acceleration is minus omega squared into a. Ide kada? Yes. Ardham cheskondi, ide jagrata. Now let me talk about position. Let me talk about the time at which the maximum speed and acceleration happen. Let us quickly go to our main slide and let us talk about acceleration ante ide me speed v is equals to omega into root of a square minus x square. So this is the speed, this is your acceleration. Andariki t not t by 2. Chusko, t by 2 is not required. See, it is t is equals to 0 kada. Yes, it came, t by 4 seconds have been gone. దాని తర్వాత మళ్ళీ ఒకసారి ఇట్ ఇస్ కమింగ్ బ్యాక్ అంటే హియర్ ఆల్సో t by 4 seconds gone అంటే t by 4 plus t by 4 అంటే t by 2 seconds. At t by 2 seconds it is coming for the first time. అంతే కదా? Yes, for the first time it is coming 0, t by 4, t by 2, 3t by 4, t. అర్థం చేసుకోండి. Let us talk about it later. I'm going to details also. Let us talk about much details. కానీ before that let us quickly go through the formula. So idante na speed ki formula, this is my acceleration ki formula. Cheppandi andariki, I am talking about maximum and minimum values ra. This slide, I would say it is one of the most important slides. Okay, this slide is actually one of the most important slides for your entire calculations. Chuskondi, we are talking about acceleration and we are talking about speeds. Ade kada? Yes. So modatiga acceleration gurinchi maatladutunnam, dan tarvata let us talk about your velocity లేదా speed, whatever you want to say. చెప్పండి, యాక్సిలరేషన్ లో కూడా నా దగ్గర రెండు కేసెస్ ఉన్నాయి రా. ఫస్ట్ కేస్ లో యు ఆర్ టాకింగ్ లేదా యు ఆర్ టెల్లింగ్ దట్ యువర్ యాక్సిలరేషన్ స్మాల్ a కదా. Yes, your acceleration small a is maximum. Your small acceleration is maximum లేదా The second case is acceleration is minimum. ఇప్పుడు చెప్పండి, వాట్ ఈస్ ద కేస్ ఫర్ మాక్సిమం యాక్సిలరేషన్ రా? యాక్సిలరేషన్ ఫార్ములా రాసుకోండి ఒకసారి. యాక్సిలరేషన్ ఇస్ ఈక్వల్స్ టు మైనస్ ఒమేగా స్క్వేర్డ్ ఎక్స్. ఇదే కదా మాక్సిమం యాక్సిలరేషన్ కోసం ఫర్ ఏ మ్యాక్స్. వాట్ డూ యూ నీడ్ రా? యూ నీడ్, చెప్పండి అందరికి, చూసుకోరా, దిస్ నెగటివ్ సైన్ is only indicating the direction. Okay, don't get confused, sir, don't get confused. This negative sign is only indicating the direction. So for maximum acceleration, magnitude of maximum acceleration, magnitude of maximum acceleration ante enti ra? Ide omega squared x kada? Yes, yes. So sir, it will be maximum when this is maximum ante your x becomes a and the maximum value of acceleration will be, cheppu, a max is equals to omega squared into a, leda a max bar is equals to minus omega squared into a. This negative sign was for directions, ante kada? చూసుకో, ఇదే, దిస్ ఈస్ ద మోస్ట్ ఇంపార్టెంట్ అండ్ ద క్రిటికల్ థింగ్ దట్ ఐ వాంట్ యూ టు నోటీస్ రా. ఎక్స్ ఇస్ ఈక్వల్స్ టు ఏ అంటే తెలుసా, యువర్ మాక్సిమం యాక్సిలరేషన్ విల్ బి అట్ ఎక్స్ ఇస్ ఈక్వల్స్ టు ఏ లేదా మైనస్ ఏ. అంటే అట్ యువర్ ఎక్స్ట్రీమ్ పొజిషన్స్ యువర్ యాక్సిలరేషన్ ఇస్ మాక్సిమం. చూసుకోండి, ఏ ఇస్ ఈక్వల్స్ టు మాక్సిమం. అర్థమైంది కదా? వాట్ అబౌట్ ద మినిమం యాక్సిలరేషన్ సార్? మినిమం యాక్సిలరేషన్ గురించి చెప్పండి అందరికి. వాట్ డూ యూ థింక్ అబౌట్ ద మినిమం యాక్సిలరేషన్? మినిమం యాక్సిలరేషన్ అంటే ఏ వాల్యూ ఇస్ మైనస్ ఒమేగా స్క్వేర్డ్ ఎక్స్ కదా. సో యాక్సిలరేషన్ మినిమం కావాలంటే ఎక్స్ షుడ్ ఆల్సో బి మినిమం రా. ఎక్స్ ఇస్ మినిమం అంటే 0 0 0. సో సార్ మినిమం యాక్సిలరేషన్ is equals to minus omega squared into 0. ఎందుకు సార్? Because it is happening at x is equals to 0 and your minimum acceleration is equals to 0 and at x is equals to 0 అంటే ఇదే. So this is my minimum acceleration point రా. చూసుకో, అంటే ఏంటి రా? When you go to the extreme points the acceleration is maximum and the mean point the acceleration is minimum. అంటే మీ acceleration is variable acceleration, it's not constant. Okay, ఎప్పటి నుంచి గుర్తుపెట్టుకోండి, మీ SHMలో యాక్సిలరేషన్ ఈజ్ ఆల్వేస్ వేరియబుల్, నాట్ అ కాన్స్టెంట్ క్వాంటిటీ. ఓకే 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 ఇప్పుడు వెలాసిటీ గురించి మాట్లాడతాము. చూసుకోండి, వెలాసిటీలో కూడా మీ దగ్గర రెండు కేసెస్ ఉన్నాయి. ద ఫస్ట్ కేస్ ఈజ్ యువర్ వెలాసిటీ, ఐ షుడ్ టేక్ ఇట్ లైక్ దిస్. ద ఫస్ట్ కేస్ ఈజ్ యువర్ వెలాసిటీ ఈజ్ మినిమం లేదా the velocity is maximum. Vmax, Vmin, అదే కదా మాట్లాడుతూ. Vmax కోసమే ఫార్ములా గుర్తుపెట్టుకోండిరా. దిస్ ఈస్ ద ఓన్లీ ఫార్ములా దట్ డిసైడ్స్ ద మాక్సిమం పొజిషన్ కావాలంటే కదా. వేర్ ఈస్ ద మాక్సిమం స్పీడ్ హ్యాపెనింగ్ అంటే యూ నీడ్ ద ఫార్ములా దట్ లింక్స్ బిట్వీన్ ద పొజిషన్ అండ్ ద స్పీడ్. ఒకటే ఫార్ములా ఉంటుంది, v ఈజ్ ఈక్వల్స్ టు ఒమేగా రూట్ ఏ స్క్వేర్ మైనస్ ఎక్స్ స్క్వేర్ కదా. Vmax కోసం v is equals to omega root of omega into root of a squared minus x squared. చూసుకో, లెఫ్ట్ సైడ్ మాక్సిమం కావాలంటే రైట్ సైడ్ షుడ్ ఆల్సో బి మాక్సిమం. ఇదే కదా? ఎస్. సో వెన్ ఈస్ ద రైట్ సైడ్ మాక్సిమం రా? ఇట్ ఈస్ మాక్సిమం when the subtracting factor x is decreasing. చూసుకోండి, x is actually reducing the value of the right side రా. So if you take the value of x is equals to 0, అదే. So that means when you take x is equals to 0, your v should be equals to omega root of a square minus 0 square. Ante omega root of a square, that is v is equals to omega into a. Chusko, your maximum velocity is coming at x is equals to 0 ante mean point. Chusko, ee case lo your velocity is maximum leda speed is maximum ra. When acceleration is minimum, speed is maximum. Ante they are opposite. And when acceleration is maximum, v must be minimum. Ide kada? You are directly looking at the results, we are saying that v minimum ante 0 leda ikkada kuda v minimum ante 0. You can see you using the results ra, minimum maximum maximum minimum ledante you can see geometrically also ra. Chusko, when the particle is coming at the extreme point, it must stop. No direction change, the direction it is changing kada. So to change the direction, the speed at the topmost point at the extreme point must become 0. If you are not understanding this way also, let us take the equation also. Cheppu. So v is equals to omega root of a square minus x square. Now v minimum kavalante this should become minimum ra. What could be the minimum value? 0. When will it become 0, sir? When root becomes 0. Root ante a square minus x square becomes 0 ante a square is equals to x square ante x is equals to plus or minus a. Ide. So x is equals to plus a leda minus a. So this is your variation of speed versus acceleration versus positions. Okay? Andariki చూసుకోండి and tell me. And when your particle is at the mean point, your acceleration becomes 0 and your speed is maximum ante a omega. Ide kada. These are the conditions ra. If any scientist, even Albert Einstein comes and tells you, sir, particle starts, చూసుకోరా, it looks a very beautiful question. Okay, it actually looks a very beautiful question. Kani there is a little mistake in that question. Nagu, I want you, all of you to tell me that mistake. Okay, so the question looks something like this: a particle, okay? Yes, a particle starts from rest, from mean position, okay? From mean position, such that its acceleration becomes 0 at the extreme position. The equation a is equals to minus 4 into 4 minus x. Find time option A 4 seconds, option B 2 root 2 seconds, option C 2 pi by pi seconds. Ade. చెప్పండి. This question is wrong. This question is wrong. Okay, the question is wrong. Wrong question, Ra. Enduku, sir? What did I say? Even if it looks a very beautiful question, it's a wrong question. Endukante chuskondi. What is the question telling? Andari. Starts from rest from mean position. Starts from rest from mean position. Starts from rest from mean position. Ide kada? No. Starts from rest from mean position ante, if this is your mean position, andariki x is equals to 0 unte, your simple harmonic motion can never start from the mean position, that too with a 0 speed. Ante start from rest and mean position not possible, ra. Chooskondi, it can start from wherever it wants, kani at the mean position the speed must be maximum. Understanding a mean position low, its speed must be maximum, ra. Maximum ante a into omega. This speed kavali. Sir, if the speed is 0, ante me a value kuda 0. Choosko. Understanding, if a omega is equals to v is 0 ante a omega 0 ante a is 0 ante, that means it is not simple harmonic. It's just a point and the particle is at rest. Are you understanding? Are you understanding? If it says that if a particle is starting from rest from mean position, not possible. It's not simple harmonic motion. Ardham chesko. Okay? Perfect. Ippudu, let us talk about the motion with some time periods. Choose. What did I say? The equation of the displacement and x is equals to a sin omega t. This is the equation of SHM kada, and it relates the position with respect to time. Kani okate condition maatrame untundi ra. What is the condition ante, sir, equation kosam you must say that the particle must start from rest. Ide kada, the particle must start from rest. What if it's not starting from rest ante? We will do some correction terms. We will add some correction terms. Are you understanding? Kani, ardham chesukondi. This is the condition where the particle must start from your mean position of the motion. Ade kada, let us take some PYQ ra. There is a PYQ. Chusko. A ante enti ra? Ee equation lo cheppandi. What is A, sir? A is the maximum value of amplitude. Ante kada? Yes. So your particle can start from this point. Chuskondi. Amplitude. Maximum, mean, left amplitude, mean, right amplitude, mean, left amplitude. Is SHM kada? Yes. It is SHM. Yes. Similarly, this is mean position. This is my amplitude. This is my second amplitude. This is SHM. Ante kada? Are these the two? No. It could be like this also, ra. This na mean position, extreme position, coming back and forth. Ledante, this is also an SHM. Ledante, hey, this is also an SHM. Or this is also SHM. Or this is also SHM. Or this is also SHM. Ante back and forth motion, ra. Whatever it is, it does not matter that your line of motion should be a horizontal leda vertical line, ra. Yedaina, if it is just performing your to and fro motion, Meeru a motion ni you can call it to be a simple harmonic motion. Okay? Ardhamaindi kada? Yes. Is there an option to delete it? No option. Anyways. Ippudu chuskondi. Now, let us take some questions, okay? Some questions. I had to take a PYQ, and you will take it after these questions. Chuskondi endariki. Minus a point. This comes out to be x is equals to a point, and this is the mean position. Kada? Yes. Mean position unte x is equals to 0. Ippudu cheppandi. Now let us understand the displacement of the particle as a function of time. Ante kada? Yes. So first of all, cheppandi sir, if omega is the angular speed, a sin omega, what is the total time period of motion, sir? Total time becomes 2 pi by omega. Ide kada? Yes. 2 pi by omega is my total time period. If the particle is starting from origin. Actually, the particle does not start from origin. Chusko. When we say physics law, whenever, wherever we say particle starts, until the observer is looking at the particle from the given point. And if it is telling that the particle is starting from origin, the particle started already. When the observer is looking at the particle, he sees that the particle is to the right. The particle is at the mean position. Now it depends if it's moving to the right side or the left side. Understanding? Whenever we say the particle is starting from rest, it does not start from rest. Okay? What happens is, it is already moving. Kani, when the observer sees at it, it is at the midpoint. Observer kosame, this particle is starting from the rest. Ide kada, t is equals to 0 ante, the time when you start observing it. Okay? Good. Choose andariki. So if t is equals to 2 pi by omega, naku positions kavali, okay? Trace cheskondira at t1 is equals to 1/4 of it, ante t by 4. Ledante, you start from like this. Let t1 is equals to 0 second. Ante 0 second tarvata, I want to find the position of the particle. Next is t2 is equals to total time by 4. Third ante next t is equals to total time by 2. Next t4 is equals to t4 is equals to 3t by 4 చెప్పండి. And lastly t5 is equals to capital T. నాకు positions కావాలిరా. నాకు positions కావాలి చెప్పండి అందరికీ. When at t is equals to 0 second, equation రాసుకోండి. What did I say? The observer started observing the particle. Ante the particle started the motion from the origin. ఇదే కదా? Right. Perfect. చెప్పండి. When the amplitude is plus a minus a. Here t1 is 0 second ante ee equation రాసుకోండి. X is equals to a times of sine of omega into t. T value 0 kada? Yes, t value 0 into x is equals to 0. That means for this equation, the particle is starting from origin. Ade kada? Yes. T2 is capital T by 4. T value enti 2 pi by omega kada? Yes. So sir, it is 2 pi by omega divided by 4 ante t is equals to pi by 2 omega. అర్థమైంది అందరికీ? Yes. చెప్పండి. Substitute this value of time in x is equals to a times of sine of omega into t. ఎందుకంటే నాకు x కావాలి కదా? So you have to substitute. So sir, it is equals to a times of sine of omega into t value ఏంటిరా? T value is pi by 2 omega. ఇక్కడ నుంచి omega gone అందరికి. A sin pi by 2. Sin pi by 2 అంటే sin 90. 1. So x is equals to a. అంటే when it is starting at t is equals to 0 from origin ante mean point kada? Yes. After 1/4 of the time interval t by 4 second, it comes to the maximum position t by 4 seconds. Okay? T is equals to t by 4 seconds. Check what? At t by 2 seconds naku position kavali sir. X is equals to a times of sine of omega into t. T by 2 ante t value ra 2 pi by omega. T by 2 ante 2 pi by omega by 2. Ante 2 gone ra pi by omega kada? Yes. So sir, a times of sine of omega into t value is pi by omega. Ekkada nunchi pi omega gone sir. X is equals to a times of sine pi. Sine pi ante sine 90. Sine 90 ante 0. Ante it comes out to be 0. So that means t is equals to t by 4 seconds. Dan tarvata t is equals to t by 2 seconds. It is coming back on the x is equals to 0 point. Very good. What about 3t by 4 sir? T by 4 is the gap. Chusko. 0 t by 4. Dan tarvata malli t by 4 ante 2t. T by 2. Again t by 4 add cheskondi, it becomes 3t by 4. Again t by 4 add cheskondi, it becomes t. Ante gap of t by 4 seconds. Ide kada? Yes. Substitute cheskori. 3t by 4 ante entira? 3 into t value 2 pi by omega. 2 pi by omega multiplied by 4 ante entira? That comes out to be cheppandi 4 gone and you are left with 3 pi by 2 omega. It is my time interval. ఈ టైం పై నాకు పొజిషన్ కావాలి. ఫార్ములా చెప్పండి సార్. x is equals to a times of sine of omega into t. ఇదే కదా? Yes sir, a times of sine of omega is omega only. Time period substitute చేసుకోండి. Time is 3 pi divided by 2 omega. ఇదే కదా sir, omega omega gone. You are left with a times of sine of 3 pi by 2. 3 pi by 2 అంటే 270 degrees రా. 270 sin 270 is -1 అంటే x is equals to minus k. That means at t is equals to 3t by 4 it comes to the left extreme position. మళ్ళీ ఒకసారి when you are writing t అంటే x is equals to a times of sine of omega into capital T కదా. Capital T is 2 pi by omega. Substitute చేసుకోరా, you will get x is equals to 0. That means మళ్ళీ ఒకసారి it comes to the same point at x is equals to t. చూసుకో 0 t by 2 t. 3 instances the particle is at the mean point. Particle is at the extreme point at t by 4 seconds, left extreme at 3t by 4 seconds. కానీ it is only valid. It is only valid when the particle started from rest and started moving to the right ra. Okay, ఇదే నా initial speed. అంటే the particle started moving to the right, then t by 4. లేదా if it is moving to the left, t by 4 will be here, 3t by 4 will be there. అంతే కదా. Very good. Next చెప్పండి. So the question looks something like this. A particle in SHM starts from rest, not start from rest, starts from mean position. Okay, it has become my habit. Starts from mean position and reaches first extreme. Okay, reaches first extreme. Reaches first extreme in 4 seconds. అంతే కదా. Yes, in 4 seconds. If the distance between mean position, extreme, okay, mean and extreme position is 4 meters, find the equation of SHM. It's a good question actually. Right? Serious ga teeskondi and try attempting this question. All of you. Andariki. We will take a break at 6 p.m. Okay? The break will be at 6 p.m. Yes. If at all you have juniors ante me brothers, chinna brothers, sisters and your relatives, okay, whatever relatives you have, leda me class lo unte juniors, the juniors who are in class 11th now, ante they have just completed their 10th, leda they are in class 11th. Okay, the only thing that you can tell them and that will be very helpful for them is tell them to start physics from kinematics. Okay, tell them to solve at least at least 400 questions. Tell them to solve at least 400 questions in kinematics. Because they do have time, kada? They do have time, so tell them to solve at least 400 questions in kinematics. That will give them a very good grip actually. Okay, right. Getting any idea, students? My dear students, ఏదైనా idea? Do you have some idea? You don't have some idea? Oh, okay. 12th lo unte you cannot say them. They are in 11th, that means they have good amount of time. Leda, if you are your relatives or juniors, they are in class 10th also, right? 10th class lo kuda you tell them to solve the laws of motion chapter untundi kada, kinematics. At least 400 questions from your kinematics. What sort of questions ra? Word problems, specifically word problems. Tell them to solve at least 200 to 300 word problems. Word problems ante enti sir? An object is at rest. Suddenly an acceleration is given to it. Find the speed after this seconds. Leda, the bullet problems, all these things. Word problems. Yes. Did you get this answer? Cheppu. So, choose good. Starts from mean position, reaches first extreme in t seconds. 4 seconds kada. Choose good. Starts from mean, reaches first extreme position in 4 seconds. Kani, ippude we have seen it kada. Yes. What did you see, ra? What did you see? Actually, it should be remembered as a rule. Ide as a rule gurtundali. Kani, very good. Object covers first extreme at t by 4 seconds. T ante total time of oscillation. Ante total time of oscillation. T by 4 is equals to 4. Ekkada nunchi t is equals to 16 seconds. Directly, it's a very shortcut formula. Ledante you have to write the equation of displacement. Chusko. X is equals to a times of sine of omega t. Ide kada starts from rest ante reach first extreme. First extreme ante enti ra? X is equals to a. So a is equals to a times of sine of omega into t. Ide kada? Yes sir. A gone. 1 is remaining. 1 is equals to sine of omega into t. Ante 1 is sine 90 kada. So omega into t becomes pi by 2. Omega into t should be equals to pi by 2. Ekkada nunchi t is equals to pi by 2 omega. Ade kada? Yes. Kani your total time of oscillation t is 2 pi by omega. And your time that is coming small t is equals to pi by 2 omega. Choose Cora. When I divide it by 1 by 4, I get pi by 2 omega. Until t is equals to capital T by 4. If you don't know this formula, you have to go through all of this. You cannot waste the time in examination hall. Kada. Ade. Kabatti, you must be good with the shortcuts. Choose ko. At least NEET walaku, I can say that you must be good with all these shortcuts. I would not recommend these approach for JEE students. They might change the conditions. But for you, the conditions are something very easy. Okay? So t 16 seconds unte sir t is equals to 2 pi by omega kada. Yes. So sir 16 is equals to 2 pi by omega. Ekkada nunchi omega is equals to 2 pi by 16 ante pi by 8 radian per second. This is your omega value. Ochindi kada. What else is given? The distance between mean and extreme position is 4 meters. Ante idena mean position, idena extreme positions. This distance is 4 meters. Ante your amplitude is 4 meters ra. A value kuda ochindi. Cheppu x is equals to a sine of omega into t. Substitute ra. A is 4. Sine of omega value is pi by 8 divided by this is the equation of your SHM. Andariki. Ochindi kada? Yes. 4 sine of pi by 8 is the equation. Andariki. ఇప్పుడు ఒకసారి మీకు ఈక్వేషన్ వచ్చిందంటే యూ కెన్ టాక్ అబౌట్ ద స్పీడ్స్ ఆల్సో, యూ కెన్ టాక్ అబౌట్ ద యాక్సిలరేషన్స్ ఆల్సో. ఓకే, You can talk about speed, you can also talk about acceleration. Next, take one more question. Hey, now I will try to cover various varieties of questions. Okay, ఒక్కొక్క variety నుంచి ఒక్కొక్క question తీసుకున్నాం చూసుకోండి అందరికి. So you take these questions very seriously, very seriously, okay? Because these questions are very important in deciding your fate. Write one more question. The question goes something like this, okay? A particle starts from SHM. తీసుకోండి అందరికి. Tell me the answer, right? All of you like the video first of all, okay? ఎందుకంటే your liking helps this video algorithm boost దానికోసం. If the algorithm has been boosted, with this video will reach to more students. Like చేసుకోండి అందరి. Like this video. Like this video. Hi. Hello everybody. Hello. Which is your favorite movies, Ra? ఒకసారి చెప్పండి. I want to know the choices of my students. What is your taste? Action movies, suspense, thriller, drama, horror, లేదంటే romantic movies, comedy movies, Okay. Okay. Okay, choose. So I have two different ways to solve this question, okay? Two different ways. Me first way, you can directly use your formula. Sir, V is equals to omega root of A squared minus X squared. Ide kada? What is it telling you? Omega value enta icharu. Did he give you the value of omega? No, he did not give you the value of omega. Kabatti, you'll have to find the value of omega. Okay? Okay, so horror. Okay. V is equals to omega into root of cheppandi A square minus X square is how much? X square ante the position kada. Half of the distance up to the X ante half of the amplitude ra. Half of the amplitude. Half of the amplitude ante A square by 4. Ide kada? Yes. So that means root 3A by 2 into omega. Naku omega value kavali ra. Omega value kavalante you understand this. Okay? If at all this is your simple harmonic motion, ide my middle point, mean point, ade kada, this is my position A by 2 ra, and this is my position A. Choose ko. 0 to first extreme varaku, the time taken is T by 4, T by 4, T by 4, and this will be T by 8 kada. T by 8? T by 8? Yes or no? Hey, if 0 to first extreme is T by 4, half extreme is T by 8. Yes or no? Yes or no? Yes or no? Okay. Okay. My question to you is, if the particle is starting from rest, మనం చూసినే కదా, it takes T by 4 seconds to go to the first extreme. దాని తర్వాత again T by 4, మళ్ళీ ఒకసారి T by 4 or T by 4. So this trend follows ante for extreme position ante amplitude T by 4, half the amplitude T by 8. Yes or not? Yes. T by 12. Okay. So to find this exact time, we require the equation. And X is equals to A times of sine of omega into T. Ide kada? Cheppandi. X value ante A by 2 should be equals to A times of sine of omega into T. Ide kada? So half is equals to sine of omega T. Choose correct. It's for the first time kada. So first time unte your omega T should be equals to pi by 6, 30 degrees. Sine half ante sine 30 degrees half kada. Yes. So sir, your omega into T should be equals to pi by 6. Ante your T is pi by 6 omega. Kani your total time is T ante 2 pi by omega. Choose ko. So 2 pi by omega, I will have to multiply it with 1 by 12 ra. Ade. Very good. It does not come at T by 8. Okay. So the first amplitude is T by 4. Kani in the middle points you cannot say that the ratio is maintained. Ante you are saying that T is equals to capital T by 12 ra. Ade. Are you able to understand? So it is T by 12. Where did it go? I don't know. What's happening? Ade. Choose ko. So it is coming at T by 12. Ante kada? Yes. So sir, you can get the value of T as capital T by 12. What is the value of T ra? The value of T given in the question is 3 seconds. So 3 is equals to 2 pi by omega divided by 12. Ledante T by 12. Ledante pi by 6 omega. Choose kora. 3 is equals to pi by 6 omega. Ekkadi nunchi omega is pi by 18. You got the value of omega. Substitute. Ledante you can do whatever you want to do. Okay. So root 3 by 2, చూసుకో. So your V is equals to root 3 by 2 into amplitude is 4, omega is pi by 18. అదే కదా. So it's 2, it's 9 అంటే root 3 into pi by 9. Pi by 3 root 3 కూడా అంట. You can take that also. Okay. So speed is equals to pi by 3 root 3 meter per second. Okay. So ఎప్పుడు we are going with a break. Break till 6:40. Okay, break till 6:40 p.m. Give me some time. Okay, I have not eaten anything. I'm hungry. I'm hungry as hell. Okay. After it, first thing that we'll be discussing is, I don't think you have got that depth in your SHM. Okay, so after your SHM, we will take some more questions. Okay, then we will talk about energy in SHM. This class will go till 9 p.m. I think till 9 p.m. Leda till 9:30. Till 9:30. 5 to 6 hours of one shot will be there. Okay. Till 9 p.m. Leda 9:30 p.m. Whatever it is. Okay. Hello, everybody. Hello. Ah, 500, huh? Hi. Okay. So, as promised, the break has been completed. And ఇప్పుడు okay, in the last question, the amplitude is 2 meters, not 4 meters. Okay, 2 meters, right? So I took 4, I believe. Okay, whatever. We can change the values, okay? So it must be 2. So 2 and take gone. So it should remain root 3 by 18 only, okay? Root 3 by 18. So that goes somewhere around 6 root 3. Perfect. Okay. So let us take a few more questions. దాని తర్వాత we will be talking about okay. తీసుకోండి ఒక question. Okay? A particle in SHM starts from rest, right? For this category, we are taking the particle has started from rest only. Good evening, Parimala. Good evening. Sorry, starts from mean position, not from rest. Okay, starts from mean position. I'm sorry. Starts from mean position. Options కూడా కావాలి. Okay, I'll give you options also. Okay. Hi, Gitanjali. చెప్పండి. చూద్దాం. What is the answer? Hi. Starts from mean, moves to a by 2 in t seconds రా. అంటే ఈక్వేషన్ రాసుకోండి. x is equals to a sin of omega t. అదే కదా, starts from rest అంటే omega t only. You understand, whenever this type of questions are given to you, ఇదే ఈక్వేషన్ యూజ్ చేయాలి. Are you understanding? చెప్పండి. సో సబ్స్టిట్యూట్ చేసుకోండిరా. ద వాల్యూ ఆఫ్ ఎక్స్ ఇస్ a by 2 కదా. సో a by 2 is equals to a times of sin of omega t. అదే, సో సార్ a by 2 gone, a gone. సో 1 by 2 is equals to sin of omega into t. అదే కదా. దిస్ ఇస్ హౌ యూ సాల్వ్ ద క్వశ్చన్స్ అందరికి. 1 by 2 అంటే సైన్ ఎంతరా? సైన్ ఆఫ్ pi by 6 అంటే సైన్ 30 కదా. ఎస్. సో యూ కెన్ సింప్లీ సే సార్ pi by సైన్ ఆఫ్ 30 degrees అంటే సైన్ ఆఫ్ pi by 6. Sin of pi by 6 is equals to sin of pi by 6 is equals to sin of omega into t. Is that right? Yes. So sir, sin gone. You say pi by 6 is equals to omega into t, and from here t is equals to y by 6 omega. That's it. So that means that t is equals to pi by 6 omega. Object will be at the half of the amplitude. ఇప్పుడు what I want is I want to calculate the time after which it will be covering the entire amplitude. అంటే ఇప్పుడు మళ్ళీ ఒక్కసారి ఈ క్వశ్చన్ రాసుకోండి. a times of sin of omega into t. x is amplitude కదా. సో a is equals to a times of sin of omega into t. ఇక్కడ నుంచి a gone. 1 is equals to sin of omega into t. అదే కదా. yes. You understand, okay? You understand. ఇక్కడ నుంచి you are getting t is equals to pi by 6 omega. అంటే you have to write the value of omega రా. omega. ఎందుకంటే times are different కదా. Time is different for this, time is different for that. Let us say t dash రా. ఇక్కడ different time ఉంటుంది కదా. సో ఇక్కడ నుంచి సింప్లీ సే సార్ omega is equals to pi by 6 into t. ఎందుకంటే omega is same for both of them. Omega remains the same. ఎందుకంటే సార్ same SHM రా. Omega is what? You go to the circular motion. A circular motion lo you can talk about the angular speed with which the objects are moving. Ade kada, that remains the same. Endukante it's the same object, same motion, right? Yes. So you can simply say 1 is equals to sin of omega into t dash. 1 ante enti ra? Sin pi by 2 kada. Yes. So sin pi by 2 is equals to sin of omega into t dash. Understanding, right? Cheppandi. sin gone. Pi by 2 is equals to omega into t dash ra. Pi by 2 is equals to omega value enta vachindi sir? Pi by 60 multiplied by t dash. Pi gone. 1 by 2 is equals to t dash into 1 by 60. Ide kada, you multiply that side. You multiply 1 by 60 goes in multiplication. So t dash is equals to 1 by 2 into 60 అంటే 1/2 into 60 is 3t. Try to understand. Okay. Okay. Next, let's see one more question and then we will be moving towards our next topic. Andari. Okay. Hi, all of you. Hi. Good evening. Hi. Particle starts from rest. Not rest. A particle starts from mean position. Okay. లేదంటే you can simply say ఇప్పుడు let us talk in terms of x is equals to 0 in an SHM. Okay, performs SHM లేదా in SHM, simple harmonic motion. Okay, and comes to x is equals to a in t seconds లేదా you can simply say in t seconds. Stop. Find the time. How will the vibe come, Ray? When you are writing, the spelling of vibe is wrong. Vibe ledu sir, కానీ the spelling of vibe is wrong only. ఎప్పుడు వస్తుంది? ఎప్పుడు వస్తుంది? చెప్పండి అందరికి. Why are you so silent, all of you? So sir. Okay. Solution goes something like this. Start from x is equals to 0. moves to the right. ఇదే నా point x is equals to a. ఎక్కడ నుంచి it comes back to the mean point. From that it will go to the left side. ఇదే కదా. So let us say ఇదే నా maximum amplitude x is equals to minus a. కానీ what it says is minus 3a by 4. I'm sorry. I'm really sorry, brothers and sisters. I'm really sorry. It should be minus 3a by 4. Okay. Yes. Only 100 marks, Hey, now I'm expecting 140, 150. You want 100. Class duration will be till 8 లేదా 8:30 depending upon the situations. చూసుకో. Minus 3a by 4 will be somewhere here. చూసుకోండి. X is equals to minus 3a by 4. ఏమైతుంది ఇప్పుడు అంటే the particle started from this point. ఈ పాయింట్ నుంచి it moved to the right side. మళ్ళీ ఒకసారి it came to the left side at the mean position only. Now it is crossing this point కదా. Yes, for the first time. First time అంటే ఇదే. This is how it goes for the first time. Okay. Nice. So you have to substitute. ఏం సబ్స్టిట్యూట్ చేయాలి సార్? వాల్యూస్ ఎక్కడ సార్? ఈక్వేషన్. ఏం ఈక్వేషన్ సార్? SHM ఈక్వేషన్. వాట్ ఈస్ దాట్ సార్? I don't know. You don't know. I don't know. Nobody knows. Let everything go on. Okay. Equation of SHM, sir. X is equals to a times of sine of omega into t. Leda, if you're not understanding all these things, chusko. I told you to remember the short trick. What is the short trick? In every SHM, the particle comes to the extreme position at t by 4. Are you understanding? It's a very best shortcut I would suggest you. Chusko. Okay, so how much time, How much time? In t seconds, kada? Yes. So, sir, small t is equals to capital T by 4. What is the value of t, 2 pi by omega. 2 pi by omega. Ante small t is equals to 2 pi by omega whole divided by 4. Ante small t is equals to pi by 2 omega. Ekkada nunchi omega value calculate cheskondi. Omega is equals to pi by 2 into t. Ide kada? Yes. Ippudu you take the same equation and that equation you substitute the value of x as minus 3a by 4. Substitute x is equals to a times of sine of omega into t. ఇదే కదా. ఈ ఈక్వేషన్ లో x కి ప్లేస్ లో సబ్స్టిట్యూట్ minus 3a by 4 అందరికి should be equals to a times of sine of చెప్పండి omega into t కదా. omega value is pi by 2t multiplied by t dash. ఎందుకంటే this t is different, that t is different కానీ omega value సేమ్ ఉంటుంది. So you can say minus 3 by 4, sir. So minus 3 by 4 is equals to sine of చెప్పండి sine of pi by 2t into t dash kada. You take everything that side, so pi by 2t into t dash is sine inverse of minus 3 by 4. T dash is equals to 2t by pi into sine inverse of minus 3 by 4. So this is the time at which it will reach that side. Very good. Okay, very good. Great. Now let us talk about some applications of SHM. Leda the special cases of SHM. Special cases anta application and both are the same. Okay, so you can simply say, sir, some of the applications are this. Choose kondi andari applications ante entira. Kani ee applications discuss chesi mundu kuda you must have the idea of the equation leda condition for acceleration in SHM ra cheppandi. So what is the condition for acceleration in SHM? The first condition is acceleration should be equals to minus omega squared into x. Ide kada, this is the mandatory condition of SHM. Hey, you see all of you. So the first application I would suggest you is the spring assembly. లేదంటే స్ప్రింగ్ బ్లాక్ రా. ఓకే, స్ప్రింగ్ బ్లాక్ సిస్టమ్స్ లేదా స్ప్రింగ్ సిస్టమ్స్. అదే Spring systems ante enti sir? Spring systems lo you remember in SHM the particle moves back and forth kada? Yes. In SHM lo your particle moves in back and forth direction ante to and fro. Okay? Imagine cheskondi. This is the wall. These are all the walls. This is the spring. ఇదే నా బ్లాక్ ఆఫ్ మాస్ m, స్ప్రింగ్ కాన్స్టెంట్ ఇస్ k. అంతే కదా? ఎస్. చెప్పండి. So now what I do is, hey, all of you try to understand. Okay, I displace this block by a displacement of x. అంటే ఏంటిరా? Now the same block has been displaced by a distance of x. అంటే the elongation in the spring that has happened now is equals to x. చెప్పండి. So displacement x ఉంటే forces చెప్పండి రా. What are the forces? What are the forces, sir? So spring force is the only force acting on the block. ఇదే కదా spring force. What is the value of spring force, sir? Minus k into x. ఎందుకు నెగటివ్ సైన్ సార్? బికాస్ యువర్ డిస్ప్లేస్మెంట్ ఇన్ ద రైట్ సైడ్. చూసుకోండి, మీ డిస్ప్లేస్మెంట్ రైట్ సైడ్ లో ఉంటే స్ప్రింగ్ ఇస్ అప్లైయింగ్ ఫోర్స్ ఇన్ ద లెఫ్ట్ సైడ్. అంటే డిస్ప్లేస్మెంట్ రైట్ లో, స్ప్రింగ్ ఫోర్స్ లెఫ్ట్ లో. ఆపోజిట్ డైరెక్షన్స్ ఉంటుంది కదా. ఆపోజిట్ డైరెక్షన్స్ ఉంటే యువర్ రైటింగ్ ఎఫ్ ఇస్ ఈక్వల్స్ టు మైనస్ కే ఇంటూ ఎక్స్. Okay, so due to this force there will be some acceleration in the blocks. ఇదే కదా న్యూటన్ సెకండ్ లా, F is equals to ma. అదే, so mass of the block multiplied by acceleration, ఇదే net force కదా, is equals to minus k into x. అందరికి చెప్పండి. సో ఇక్కడ నుంచి you can simply say a is equals to minus k by m. లేదా you can write like this. a is equals to minus k by m into x. కానీ ఈక్వేషన్ ఆఫ్ SHM కంపేర్ చేసుకోండి, you get omega squared is equals to k by m. ఇదే కదా. What about the value of omega రా? Omega is equals to root of k by m. This is the first value. అందరికి జాగ్రత్తగా వినండి. This is the first formula I want you to understand. లేదంటే you can also say spring constant k is equals to m into omega squared. Okay? These are the two formulas. అంటే ఏంటిరా? If I have a particle that is doing SHM, ఇదే నా point x equals to 0, my first extreme position x equals to a, second extreme position x is equals to minus a. Moving back and forth kada, same thing happening here also ra. Surface is smooth unte the block will also perform back and forth motion ante SHM unte you can simply say, sir, time period of SHM can be given as what formula ra? T is equals to 2 pi by omega kada, 2 pi by omega 2 pi by omega. ఇదే నా టైం పీరియడ్ ఆఫ్ SHM. ఒమేగా వాల్యూ ఎప్పుడు రాసును కదా, you substitute the value of it into, you say time period 2 pi by root of k by m. ఇదే కదా. Simplify. Time period of oscillation 2 pi root of m by k. ఇదే చాలా ఇంపార్టెంట్ రిజల్ట్ and I want all of you to remember this. అందరికి. Okay? This is the time period of oscillation of a spring block system. 2 pi root m by k. And it depends on the mass of the block, and at the same time it depends on the spring constant k of the spring. అర్థమైంది అందరికి? ఓకే ఓకే. సో కాంబినేషన్స్ ఆఫ్ స్ప్రింగ్స్ ఉంటే ఏమైంది? కాంబినేషన్స్ ఆఫ్ స్ప్రింగ్స్ ఉంటే ఏం చేయాలి రా? ఫర్ ఎగ్జాంపుల్ ఐ విల్ టెల్ యూ సంథింగ్ లైక్ దిస్. చూసుకోండి అందరికి. ఓకే, బిఫోర్ దాట్ లెట్ us take some questions, all of you. Okay, question is, find time period of oscillation. దీంట్లో ఇట్స్ ఆఫ్ ఫస్ట్ కేస్. ఓకే, ఫస్ట్ కేస్ అంటే దిస్ ఇస్ అ స్ప్రింగ్. అందరికి జాగ్రత్తగా వినండి. దెన్ దిస్ ఇస్ అ బ్లాక్ ఆఫ్ మాస్ 10 kg and the spring constant k is equals to 100 Newton per meter. For the following also find amplitudes రాసుకోండి. Let us see how many of you can solve it. ఓకే, 2π/√10 కదా. ఓకే, ఇప్పుడు ఆంప్లిట్యూడ్ గురించి చెప్పండి అందరికి. వాట్ ఈస్ ద ఆంప్లిట్యూడ్? వాట్ ఈస్ ద ఆంప్లిట్యూడ్ రా? వాట్ ఈస్ ద ఆంప్లిట్యూడ్? వాట్ ఈస్ ద ఆంప్లిట్యూడ్? ఆంప్లిట్యూడ్ చెప్పండి. It's a very famous question, okay? Very famous, very elementary, very 1 + 1 = 2 type question, okay? No, not 1 meter. Amplitude equals to 1 meter is wrong. Endukante if it amplitude is 1 meter, it will not perform simple harmonic motion. 1 meter complete chesina tarvata, it will slowly come to that point. Ante that is the mean position of the object. 1 meter is the mean position. Yeah, you can say, oh, I'm sorry. Amplitude is 1 meter. Ippudu that depends on how you are telling it, Ray. What is the mean position ante? Now you might get confused. So if you are assuming that the amplitude is 1 meter, it has two different ways to address. The first way is you are assuming your mean position to be here only, Ra. The mean position, where is the mean position andariki? Okay, చూసుకోండి. ఏమైతుంది అంటే as soon as you release this block, it will go down. Okay, there will be elongation in the spring. So let us say this is the maximum displacement. My question is this the maximum amplitude? Is this the maximum amplitude? Yes or no? Is this the maximum amplitude, Ra? You release the block, you release your hand, it goes to the maximum and come up some, kada? So ఈ distance అంటే maximum amplitude, అవునా కదా? No, this is not the maximum amplitude. It is 2 times the maximum amplitude. Endukante your mean position will be somewhere here, ade, and this distance will be elongation x, that is equals to mg/k. Understanding idi kuda, this distance x is equals to mg/k. Ela ochindi sir? You can simply say this is the equilibrium position, ra. Final equilibrium position, ante kada. Yes, sir. Equilibrium position. Now, you understand. Equilibrium position and entira. You slowly remove it. You slowly let it come down. Slowly. So it will stop here, right? It will not come below this. Ide na equilibrium position X unte, spring force is acting in the vertically upward direction. Equal kada. So Kx is equals to mg unte. You can simply say X is equals to. So this is your amplitude, either mean position, right? And the particle will go completely up and down motions. Time period is equals to 2 pi into root of m by k, okay? So that means 2 pi into root of mass is 10, k is 100 and 2 pi by root 10. Okay, this is our time period. What about amplitude, sir? Amplitude is equals to mg by k and 1 meter itself, correct? 100 divided by 100. That means 1 meter of amplitude is చూసుకోండి. Correct. ఇప్పుడు let's talk about combinations of spinning. Series lo unte emaitadi, parallel lo unte. The best example for your series will be either this is your first spring, and immediately next to it is your second spring. Okay, and either me block mass m, spring constant k1, spring constant k2. You push it, you leave it, it will perform SHM. ఈ SHM కి టైం పీరియడ్ కావాలి. ప్యారలల్ లో ఉంటే చూసుకోండి, ప్యారలల్ లో ఉంటే దిస్ ఈజ్ యువర్ సిస్టమ్ అంటే దిస్ బికమ్స్ యువర్ ఫస్ట్ స్ప్రింగ్ కాన్స్టెంట్ ఇస్ k1 అండ్ ఇదే మీ సెకండ్ స్ప్రింగ్ కాన్స్టెంట్ ఇస్ k2. ఓకే, ఇదే k2. మాస్ m ఉంటే చెప్పండి వాట్ విల్ బి ద టైం పీరియడ్స్ ఆఫ్ ఆసిలేషన్స్ చెప్పు అందరికి. సార్ series unte you can replace your spring knet is equals to k1 into k2 divided by k1 plus k2. ide kada re I told you about your capacitors also, we talked about your resistors also, we talked about your inductors also. You are still not understanding ante your something is missing. Try to understand. Okay, try to understand. rendu springs unte this is how you write the net spring constant formula. Ide kada? Yes, cheppandi all of you. So you can simply say, sir, time period is equals to 2 pi root of mass of the block divided by k net ra. That means 2 pi root of mass divided by k net ante k1 k2 divided by k1 plus k2. Ide kada? Very good. ఇప్పుడు రీరైట్ లేదా రీఅరేంజ్ ఏదైనా చేయొచ్చు. యూ కెన్ డూ వాట్ ఎవర్ యూ వాంట్, బట్ గివ్ మీ ద రిజల్ట్స్ రా అందరికి. పర్ఫెక్ట్ సార్. వన్ ఫైనల్ రిజల్ట్ అంటే ఇదే. సో టోటల్ టైం పీరియడ్ ఆఫ్ ఆసిలేషన్ ఇస్ 2 pi root of m into in bracket k1 plus k2 divided by k1 k2. అర్థమైంది? ఏబుల్ టు అండర్స్టాండ్, నాట్ ఏబుల్ టు అండర్స్టాండ్ చెప్పు. ఎక్కడ వచ్చి సింప్లీ సే సార్ knet is equals to k1 plus k2. So sir, here the time period is equals to 2 pi root of mass divided by knet అంటే t is equals to 2 pi root of mass is m, knet అంటే k1 plus k2. Okay. Hey, ide time period of series kada, and this is time period of parallel kada. What will happen if we multiply ra? Cheppandi okasari. Leda what will happen if we divide? Cheppu all of you. Okay, let us do multiplication only. Cheppandi. So you can simply say, sir, time period of series into time period of parallel springs series unte 2 pi root of m into k1 plus k2 divided by root k1 k2 kada, yes, multiplied by 2 pi root of m divided by k1 plus k2. ఇక్కడ నుంచి k1 plus k2 gone. 2 pi into 2 pi becomes 4 pi squared into m divided by root of k1 into k2. So this is time period of series into time period of parallel springs combination. Am I correct? Yes, you are correct. Correct kada? Sir. Let us talk about pendulum. Okay, pendulum. The second case is pendulum. Okay, pendulum ante it is a special case of me angular SHM. Angular SHM ante enti sir? Angular SHM lo your particle is not moving in a straight line, rather than that it is moving in a curved path. Ardhamaindi andariki? It is moving in a curved path. So if this is your mass m, length l, suspended something like this, moves something like this in a curved path kada? Yes, ade. Are you able to do it? Are you able to do it? You can do it. For sure you can do it. Jagrataga vinandi chuskondi. So let us compare about linear SHM versus angular SHM ra. Chusko. So let us quickly go through linear and angular. I'm not wasting too much time, okay, in angular SHM. Chusko. Ide me linear SHM. Linear SHM gurinchi meeku mottam telusa kada? Yes, and this is your angular SHM. Ade, if you are good with your rotational dynamics and rigid body dynamics, 6-hour one-shot video that we took, linear SHM lo your acceleration is minus omega squared into x. Ide kada? Me angular SHM lo alpha, angular acceleration alpha should be equals to cheppandi minus omega squared into theta. Ide. This is a difference ra. Ade. Ide kada? Time period is equals to 2 pi root of m by k. 2 pi root of m by k. Ekkada vachi your time period t is equals to 2 pi root of I divided by mgl. Mgl ante torque. Mgl kada? Mgl. Hey, not required all of these things, Ray. Let it be. Okay? You just remember the time period of oscillation. If I go in these things, then it might take one more session for a separate session discussing angular SHM. There are too much things. Okay? Then you have your complex. I don't know if I should tell these things or not. You just remember, pendulum is something that we'll be discussing at the end if we get time. Okay, if we get time. I have to discuss your energy in SHM, and then we have to take some general cases. Okay, dan tarvata we will be talking something more about angular SHM. Okay, we will talk. Chusko. Let us talk about energy in SHM. Andariki. Yes, let's talk about energy in SHM. But before talking about energy in SHM, we will not take general cases. General cases ante enti sir, you have a particle placed at the mean position. Ekkadi nunchi it is attaining first extreme position x is equals to a. Dan tarvata it is going to the next extreme position x is equals to minus a. We will not be taking this case ante whenever we are talking about energy, to simplify up the things, we will be using applications. Applications ante enti sir, spring block system use cheddam. Imagine cheskondira andariki spring constant k, mass is okay, right. Initially there is this system ante nothing was there. This block is also happily resting, spring is also happily in a natural position. Koncham samayam tarvata you came and you pulled this block by a distance of a. Jagrataga vinandi andariki. You pulled this block by a distance of d. Ledante we will take a little more distance. Okay, chusko. After some time you came and you pulled this spring by a distance of d. Ante kada? Yes. Ippudu emaitadi ante this block, it will keep on oscillating between these two lines and x is equals to 0 to x is equals to d. Mari amplitude enti sir? Amplitude is half of the total distance kada? Yes. So your amplitude is somewhere here chuskondi. So this is your amplitude ante d by 2. Ikkada kuda your amplitude is d by 2. Ardhamaindi andariki? Yes. Are you understanding? This is how those things look like in spring block system. Andariki vinandi. Now when I say, chusko all of you, when I say there is some random amplitude leda some random distance x has been moved, all of you listen to me very carefully. When I say the random distance ante x has been moved, eppudu cheppandi what all amount of energy is it having ra? Cheppu all of you. Can I say sir the block has two types of energies? So total energy is equals to your kinetic energy plus your potential energy. Ardhamaindi andariki? Are you understanding? Yes. Cheppandi sir, what is the kinetic energy? Kinetic energy ante half mv squared. Potential energy, ippudu let us talk about the potential energy of the spring. What is the potential energy of the spring sir? The potential energy of the spring, displacement x untundi kada, so the potential energy is simply equals to half k x squared. Ade. Try to understand, okay? Try to understand. No. A little mistake happened, ra. A little mistake happened. Chuskondi. This is not the scenario how it looks. Andariki. It is not how it looks, okay? It is not how it looks. It is not how it looks. Leda, I will just take that vertical spring problem only. Chusko. Mass m kada, spring constant k. What is the equilibrium position ra? Equilibrium position is this. And amplitude enti sir? Amplitude is equals to a is equals to mg by k. Ide kada? And what about the bottommost position? Ekkada kuda the amplitude is mg by k. Ide kuda na amplitude ra. So this is my equilibrium position. And at this instance the value of x should be equals to mg by k. X should be equals to mg by k, and whatever distance we will be calculating up and down, we will be calculating with respect to this position only. Ardhamaindi andariki? Right. So when you are writing this equation, x is the distance of the particle from the mean position. Choose ante try to substitute the formulas. Half m into v square. V is what? V and t. What is the value of v, sir? What is the value of v, sir? What is the value of v, sir? V is nothing but omega root of a square minus x square. Gurtunda? Something like this. You remember this? Okay. Whole square, v square ante ee mottam ki whole square plus half k x square. K ante what? What is the value of k? Do you remember I told you time is equals to 2 pi root of m by k. Leda, we also said k is equals to m omega squared. I don't know if you're understanding this or not. So it is half times of m times of square chestundi okasari. It becomes omega squared into a squared minus x squared. Jagradaga plus half into k ante endira m omega squared into a squared. Ide kada? Yes. Multiply half m omega squared a squared minus half m omega squared x squared plus half, sorry, it should be x squared, right? It should be x squared plus half m omega squared x squared. Choose code. This gone. Total energy can be given as half m omega squared x squared. This is your energy of the particle performing simple harmonic motion. Okay, ide me energy ra andariki vinandi. So this is your energy of the particle that is performing your simple harmonic motion. Let us do one thing. Okay, let us take a general case. Dan tarvata we will be doing some questions. If possible, if time is there, we will take angular SHM also. Okay, right. So equation of SHM గురించి మాట్లాడుతున్నాం చూసుకోండి అందరికి. Equation of SHM. What was the equation, sir? What was the equation, sir? X is equals to a times of sine of omega t. ఇదే కదా. కానీ ఈ ఈక్వేషన్ తోనే I have also given you one instruction. That instruction was this equation is valid only when the object is starting from rest. అర్థమైంది అందరికి. What will happen if the object is not starting from rest ante? We will draw a circle. We will draw a circle. Jagrataga చూసుకోండి అందరికి. So ఇదేనా circle కదా? Yes. So let us do one more thing. Let us try to join the ends of this circle. Projection తీసుకున్నాను చూసుకోండి. So this ఇదే అంటే నా mean position x is equals to 0. ఇక్కడ వచ్చి ఇదే నా extreme position x is equals to plus a and here it is x is equals to minus a. అంతే కదా? Yes. Mean position లో ఉంటే you try to substitute ra. It is only valid when the particle starts from mean position. SHM లో కానీ let's go back to the original ante your circular motion ra. It is only valid when the particle starts from the topmost point. చూసుకో ఇదే అదే కదా. Yes, very good. So sir, you try to understand. Okay, this was my initial position. Koncham samayam tarvata the object has came to this point ra ante angular speed omega time t ante this angle became omega t. Kabatti the same omega t is coming in this expression. What will happen if the particle doesn't start? Chusko. What will happen if the particle does not start from the same position? Ante let us take any general position of the particle and let us try to do the calculations. Chuskondi andariki. So ide my plane leda my projection is on this line kada. And let us imagine that the particle does not start from the origin ra. Oka general point తీసుకోండి. Let us say the particle is starting from this point ra. అంటే ఏంటి రా? ఇనీషియల్ యాంగిల్ ఇస్తుంది కదా. ఇనీషియల్ యాంగిల్ వస్తుంది రా చూసుకోండి. సో దిస్ ఈజ్ మై ఇనీషియల్ యాంగిల్. ఆల్రెడీ ఇట్ హ్యాస్ కవర్డ్ ఆల్ఫా. ఇప్పటి నుంచి ఐ స్టార్టెడ్ టు వాచ్ దిస్ ఆబ్జెక్ట్. అంటే మళ్ళీ ఒకసారి టైం టీ తర్వాత చెప్పండి యాంగులర్ స్పీడ్ ఒమేగా ఉంటే టైం టీ తర్వాత దిస్ ఈజ్ ద యాంగిల్ కవర్డ్ బై పార్టికల్ అంటే ఒమేగా ఇంటూ టీ. ఇదే కదా. Yes, కానీ అవర్ ఫ్రేమ్ లేదా అవర్ బేస్ ఆఫ్ ద అబ్జర్వేషన్ ఇస్ జస్ట్ స్టార్టింగ్ ఫ్రమ్ దిస్ సైడ్. చూసుకోండి when I'm dropping this perpendicular రా ఈ మొత్తం యాంగిల్ ఒమేగా టీ ఉంటే దిస్ ఇస్ ఒమేగా టీ. ఎక్కడ కూడా డ్రాప్ ద పర్పెండిక్యులర్ ఆల్ ఆఫ్ యూ చెప్పండి ఈ మొత్తం యాంగిల్ చెప్పు ఒకసారి. alpha plus omega t, same angle will be this. Ante this angle will become alpha plus omega t. Leda omega t plus alpha kada? Yes. So instead of this omega t, we will be substituting omega t plus alpha. Chusko. So here the equation transforms to x is equals to a times of sine of omega t plus alpha. What is alpha, sir? Alpha is the initial displacement. Displacement ante kada? Initial angular displacement ra. Initial angular displacement. Little long name, sir. So let us shorten the name ra. It is known as initial phase. Initial phase of SHM. Chusko. So this is the initial phase. Ante enti ra? Ee equation lo if you are substituting the value of t is equals to 0, idi gone kada? So x is equals to a sine of alpha. Chusko. A sine alpha ante this. This is the distance at which the particle started. Are you able to understand? If you are understanding well and good. If you are not understanding, formula gurtupettukondi ade. So ఇప్పటిదాకా what we have discussed is a sin omega t. కానీ ఎక్కడి నుంచి అంటే ఈ టైం నుంచి till your exam రా, ఇప్పటి నుంచి ఎగ్జామ్ వరకు the general equation of SHM will be x is equals to a times of sin of omega t plus delta లేదా alpha లేదా phi, whatever you want to call, you can call it. Okay, phase ఉంటుంది కదా. So let us call that initial angle to be phi. Here I told you that angle is alpha. You can say alpha లేదా you say phi ra. Okay, widely accepted అంటే famous అంటే phi అంటే phase, initial phase. Okay, initial phase ra. Okay, good. What about speed, sir? Same, right? Nothing will change, sir. Omega into a into sine of omega t plus phi. And speed remains same. What was the relation between speed, ra? Speed is omega root of a square minus x square. What about acceleration, sir? Acceleration is minus omega squared into a times of sine of omega t plus phi. Chusko. Ee mottam ante x kada. Substitute a is equals to minus omega squared into x. Nothing has changed, ra. Only the phase has changed. Ante kada? Yes. So if you are saying, sir, chuskondi. Ide me SHM, this is your mean position x equals to 0, x equals to minus a, and here x is equals to plus a unte, your particle is starting at a general point ra. General point unte, you will have to introduce x is equals to a times of sine of omega t plus extra quantity, ide phi. So how to find the value of phi, sir? If phi ki value find cheyadaniki meeku ee distance gurtundali. It must be given to you, okay? If it's given to you, then no problem, right? Let us take a question from this. Okay, a particle starts. Performing simple harmonic motion. Performing SHM from x equals to a by 2. Full stop. If the amplitude is a, okay? If the amplitude is a, let us also give value of a is equals to 10 meters. Andariki. Okay, if amplitude a is equals to 10 meters. And initial speed of the particle తీసుకోండి. Okay, nobody has given me the right answer yet. Yep. A by 2, కానీ the value of A is 10. అంటే మొదటిగా x is 10 by 2 అంటే 5 meters కదా. Yes. Initially at t is equals to 0, అందరికి చూసుకోండి. Very good. Very good. At t is equals to 0, మీ x కి వాల్యూ ఏంటంటే 5 meters. Equation, it is not starting from the origin kada, అంటే mid point, mean position. కాబట్టి its equation will be having some phase difference. Okay, so the equation looks something like this. X is equals to a times of sine of omega t plus the value of phi. ఇప్పుడు నాకు వాల్యూ ఆఫ్ a కావాలి, ఒమేగా కావాలి, phi కావాలి రా. a వాల్యూ ఆల్రెడీ ఉంది నా దగ్గర కదా. ఇప్పుడు I want omega and phi. How to do it, sir? You do one thing, substitute the value of t equals to 0 ra. t 0 పెడితే omega t gone కదా. Yes, x value ఏంటిరా? 5 is equals to a value is 10 into sine of, చెప్పండి, omega t gone ఎందుకంటే t value 0 రా. t is equals to 0 substitute చేసిన తర్వాత చూసుకోండి, it is only 5 కదా. Yes, 5 is 10, 10 that side, 5 by 10 అంటే 1 by 2 రా. 1 by 2 డైరెక్ట్లీ రాస్తున్నాం చూసుకోండి. 1 by 2 is equals to sine 5. 1 by 2 అంటే sine 30 degrees కదా. Yes, so sine of pi by 6 is equals to sine 5 ra. ఇక్కడ నుంచి you can directly say, sir, phi value is equals to pi by 6. అంటే you got two things there. First is you have the value of a, you also have the value of phi. ఇప్పుడు the only thing that you want is omega. ఈ omega కోసం I already given you the value of u, అంటే v is equals to omega root of a squared minus x squared ra. At t is equals to 0 substitute చేసుకోండి. The value of x is 5 కదా. Yes. So sir, speed ఎంత 10 into root 3 is equals to omega into root of a square అంటే 10 square అంటే 100 minus b square అంటే 10 by 2 అంటే 5 square అంటే 25 ఇదే కదా. Yes. So 10 into root 3 is equals to omega into root of 75. జాగ్రత్తగా వినండి, ఇదే కదా. So 10 into root 3 is equals to omega into root of 25 into 3. 75 into 25 into 3 కదా. You take the square root. So sir, 5 into omega into root 3 is equals to 10 into root 3. ఇక్కడ నుంచి root 3 gone ra. 10 is equals to 5 into omega. And here onwards, omega is equals to 10 by 5 అంటే 2 radian per second. ఇదే వచ్చింది, మొత్తం వాల్యూస్ వచ్చిందరా. Substitute x is equals to a అంటే 10, sin of omega అంటే 2 into t plus 5 అంటే pi by 6. So ఇదే, this is your equation of SHM. Good, very good, very good, very good, very good. Okay, right. ఇప్పుడు ఎనర్జీ కంప్లీటెడ్ కదా. ఎస్. సో ఎనర్జీ ఇన్ ఎస్హెచ్ఎం, మళ్ళీ ఒకసారి చెప్తాను చూసుకోండి రా. ఎనర్జీ ఇన్ ఎస్హెచ్ఎం అంటే ఇట్స్ అ కాన్స్టెంట్ టర్మినాలజీ రా. కాన్స్టెంట్ టర్మినాలజీ అంటే ఏంటి సార్? ఎనర్జీ ఇస్ ఈక్వల్స్ టు కైనెటిక్ ఎనర్జీ ప్లస్ పొటెన్షియల్ ఎనర్జీ. యూ డూ వాట్ ఎవర్ యూ వాంట్ డూ, బట్ ద టోటల్ ఎనర్జీ ఈజ్ హాఫ్ m omega squared a squared. A అంటే amplitude, maximum amplitude of SHM. Sometimes kinetic energy decreases, at the same time potential increases. లేదా potential decreases, kinetic increases రా. Are you understanding? Whatever is happening, కానీ the addition of these two remains the same. ఎంత సార్? half m omega squared a squared. అదే కదా. Yes. So if you're talking about the graph, should I give you? లేదా let it be, not required. Not required. చూసుకోండి. So let us talk about some questions based on the energy. జాగ్రత్తగా వినండి. Have to randomly generate the questions, that is the problem. I don't have to do any mistakes. Moves in SHM starting from towards right. Sorry. Okay. Not understanding, sir. Not understanding anything కదా. ఓకే, చూద్దాం చూద్దాం. Okay, mass is 10 kgs, sir. M is equals to 10 kgs. ఇదే కదా. What else information given రా? Amplitude. మీకు ఎనర్జీ గురించి మాట్లాడుతున్నాం అంటే యూ కెన్ సింప్లీ సే సార్ టోటల్ ఎనర్జీ ఆఫ్ SHM is equals to half m omega squared a squared. అంతే కదా. ఎస్, వెరీ గుడ్, వెరీ గుడ్. మాస్ ఐ డూ హ్యావ్, ఆంప్లిట్యూడ్ ఐ హ్యావ్, ఒమేగా ఐ డోంట్ హ్యావ్. మరి ఏం చేయాలి? క్యాలిక్యులేట్ చేయాలి. ఒమేగా ఎలా క్యాలిక్యులేట్ చేస్తా సార్? రైట్ ద ఫార్ములా. ఏదైనా యూ వాంట్ యూ కెన్ రైట్ ద ఫార్ములాస్ రా. చెప్పు. What is it saying? Time required to reach the amplitude is 1/4 pi seconds. ఇదే కదా. ఈక్వేషన్ రాసుకోండి. ఫస్ట్ ఆఫ్ ఆల్ x is equals to a times of sine of omega t plus 5. ఎందుకు 5 సార్? బికాస్ ద పార్టికల్ is not starting from origin రా. చూసుకో, starts from x is equals to 4 meters kada. So at t is equals to 0, start ante 0, t equals to 0, start ante t equals to 0. So if you are using two terminology, the first term is start ante t equals to 0 and x is equals to 4 meters. ఇదే కదా. ఈ మొత్తం వాల్యూస్ ని సబ్స్టిట్యూట్ చేసుకోండి ఒకసారి. సో 4 is equals to ఆంప్లిట్యూడ్ నా దగ్గర ఉంటుంది కదా. సో ఇట్స్ 4√2 into sin of omega t. t is 0 వచ్చింది కదా. సో ఆటోమేటికల్లీ ఇట్ గెట్స్ క్యాన్సిల్డ్ and I'm only left with 5 రా. జాగ్రత్తగా చేసుకోండి. సో 1 by డైరెక్ట్లీ రాస్తున్నాను చూసుకోండి. 1/√2 is equals to sin 5. 5 అంటే you can simply say sir the value of phi is pi by 4. ఎందుకంటే sin 45 is 1 by root 2 రా. 45 అంటే pi by 4. 45 అంటే pi by 4 ఇదే కదా. ఎస్, నాకు 5 వాల్యూ వచ్చింది. ఎప్పుడు ఏం చేయాలంటే యూ సబ్స్టిట్యూట్, మళ్ళీ ఒకసారి యూ హ్యావ్ టు సబ్స్టిట్యూట్ ద థింగ్స్ రా. చూసుకో, టైం రిక్వైర్డ్ టు రీచ్ ద యాంప్లిట్యూడ్ ఇస్ 1 by 4 కదా. సో ఇప్పుడు ఇదే ఈక్వేషన్లో x is equals to a times of sin of omega t plus 5. ఈ ఈక్వేషన్లో యువర్ x is equals to amplitude. It has reached to the amplitude kada. So x is equals to a times of sin of omega into time ఎంత వస్తుందిరా 1 by 4 pi kada. Yes, plus 5 value is 1 by pi by 4 pi by 4 sorry, so it's pi by 4 అంతే కదా. a gone అంటే 1. సో 1 అంటే sin pi by 2 రా. సో sin of pi by 2 equals to sin of చెప్పండి omega divided by 4 pi plus pi by 4 ఇదే కదా. sin gone. Pi by 2 is equals to omega by 4 pi plus pi by 4. You take it that side. చెప్పండి అందరికి pi by 4 is gone కదా. So you are left with pi by 4 is equals to omega upon 4 pi. Yes, omega by 4 pi అదే ఇదే కదా. రైట్, 4 కూడా gone రా. అంటే ఏంటి సార్, your omega is equals to pi squared. అర్థమైంది? Yes, omega is pi squared. The value of pi squared is approximately equals to 10. Okay, if you want to take pi squared, pi squared. If you want to take 10. అదే చెప్పరా. ఇప్పుడు the value of energy in SHM అంటే energy is equals to half m omega squared a squared. Half is half, mass is 10, omega squared is pi squared whole square ra, into amplitude square is 4 root 2 whole square. ఇదే కదా. 2 1s are 2, 2 5s are 10 అంటే 5 into 4 root 2 whole square directly 32 multiplied by pi to the power 4 ఇదే. సో 32 into 5 becomes 160 ఇదే కదా. ఎస్, 160 into pi to the power 4 joules. ఇదే నా టోటల్ ఎనర్జీ వచ్చింది. చూసుకోండి ఏదైనా. if someone has any doubts, keep it clear. Okay, half an hour your class will be completed. Okay, the only thing that I want to discuss to you now is your angular SHM. Again mallira, I will not go into the depths of it. Let us just go through quickly ra. Okay, so I'll just tell you the formulas. Good pettukondi sir ela ochindi, how do you do ante I will not take that much things. Okay, you want to explain it again? Chusko. What to explain? Everything has been written. What to explain? You see, you go back and you see it once again. Okay? You see it once again. Just so now, let us talk about your angular SHM. Angular SHM ante I'm really lazy to explain this topic. It needs a whole lecture actually, to be honest. How did it come? How did that come? Yeah. Who else is there? Sorry, let it be. Me linear SHM versus angular SHM. Should I directly you do the comparison? Let us directly. Okay, first let me talk about your angular SHM. Chuskondi. In your angular SHM, most of the times the particle moves in a circle. Circle ante something like this. For example, your pendulum, ledante your physical pendulum kuda antaru. Physical pendulum lo you can take any object like this chair, okay, like this chair, and you can send it in SHM, something like this ra. Chuskondi. So this is SHM, okay. This is also angular SHM, kani it's a physical pendulum. Chala heavy ra. Chusko. Are you understanding? In SHM, the things go something like this. Are you able to understand? This is how known as angular SHM, right? Chusko. This is your angular SHM. Chuskondi. So, in angular SHM lo, you have the same things. Same things ante enti sir. In your linear SHM, you used to have a mean position. ఎక్కడ కూడా you do have a mean position. చూసుకోండి, ఇదే మీ mean position రా. This is how your mean position looks like. This. What about the extreme position, sir? This is your first extreme position. మళ్ళీ ఇదే మీ సెకండ్ ఎక్స్ట్రీమ్ పొజిషన్. యాంగిల్స్ ఎప్పుడు ఇన్ యువర్ లీనియర్ SHM we used to talk about లెన్స్ కదా. హియర్ విల్ టాక్ అబౌట్ యాంగిల్స్ రా. చూసుకోండి, దిస్ యాంగిల్ అంటే మాక్సిమం యాంగిల్ కదా, theta naught అంటారు. హియర్ ఆల్సో దిస్ యాంగిల్ ఇస్ మాక్సిమం యాంగిల్ అంటే ఇట్ బికమ్స్ ఆంప్లిట్యూడ్, యాంగులర్ యాంప్లిట్యూడ్. చూసుకోండి, theta naught అంటే ఏంటిరా? theta naught is your angular amplitude. Okay, theta naught is your angular amplitude. Okay, what about angular speed, sir? Your angular speed is omega. Choose this, whatever angular speed you have, it is known as omega. Ade kada? Yes. Omega ante it is your angular. Okay, what about angular acceleration, sir? Alpha ante ide మీ angular acceleration. Okay, right. ఇప్పుడు let us compare between linear SHM and angular SHM. Okay, linear SHM versus angular SHM. What are the differences and what are the similarities? Same similarities and differences ఉన్నాయి, చూసుకోండి. linear SHM versus angular SHM. చెప్పండి, వన్ బై వన్ ఫార్ములాస్ చెప్పండి. ద ఫస్ట్ ఈజ్ యువర్ ఈక్వేషన్ కదా. ఎస్, సో ద ఫస్ట్ ఈజ్ యువర్ ఈక్వేషన్. వాట్ ఈస్ ఈక్వేషన్, సార్? ఎక్స్ ఈజ్ ఈక్వల్స్ టు ఏ టైమ్స్ ఆఫ్ సైన్ ఆఫ్ ఒమేగా టీ ప్లస్ 5. ఇదే కదా. ఇక్కడ కూడా ద సేమ్ ఈక్వేషన్ కమ్స్ ఇన్ టు ద సినారియో. అదే he was write the same thing, sir. X అంటే random distance కదా, సో ఇక్కడ కూడా random angle theta. A is the special distance, amplitude అంటారు. ఇక్కడ కూడా this becomes theta naught into sin of omega t plus 5. ఇదే. ఓకే, రైట్. వాట్ అబౌట్ స్పీడ్స్ రా? స్పీడ్స్ చెప్పు. స్పీడ్ is equals to a omega sin of omega t plus 5. లేదంటే you also write it omega root of a square minus x square. ఇదే కదా. This is your speed in linear SHM. ఎక్కడ వచ్చి in your angular SHM you say omega is equals to theta naught into sine of omega are different, okay? This omega and that omega is different. So you can simply say, sir, angular speed omega dash is equals to theta naught into omega into sine. Sorry, not sine, it should be cos. It should be cos. It should be cos. A omega cos of omega t plus 5. Here theta naught into omega into cos of omega into t plus 5. Leda, you can also say, sir, omega dash is equals to omega into root of a square ante theta naught square ra minus theta square. Ide kada. What next, sir? Linear acceleration a is equals to minus omega squared into x. ekkada vachi your angular acceleration alpha becomes minus omega squared into theta. So these are all the formulas. Next we talk about your time period ra. Okay, okay, so let us take spring force versus angular pendulum. Okay, లేదా pendulum చెప్పండి అందరికి. వాట్ వి సే రా, స్ప్రింగ్ లో దిస్ ఈజ్ మై స్ప్రింగ్. ఓకే, లెట్ us say mass m, displacement రా అంటే maximum angular amplitude a is there and general displacement is x. చెప్పు, what did we say, sir? F is equals to minus k into x. F అంటే ఏంటి రా? mass into acceleration కదా. yes, is equals to minus k into x. ఇక్కడ నుంచి acceleration is minus k by m into x and you got a should be minus omega squared x. ఇదే SHM equation, కంపేర్ చేసుకోండి. omega square is equals to k by m. అదే. When you come here pendulum, things get replaced ra. linear లో whatever role your force is playing, in angular torque plays the same role. అదే కదా? yes. గుర్తుందా? rotational motion sir ji, rotational motion. So this was my natural position. ఇదే, this is my general position, angle theta రా, చూసుకోండి అందరికి. mass mg is acting in the downward force, mg force downward రా, length is l. అందరికి చెప్పండి, what is the torque రా? torque is r bar cross f bar. గుర్తుందా? r bar cross f bar అంటే ఏంటి sir? You take two things. What are the two things? చెప్పు all of you. So can I simply say, sir, torque is equals to r bar cross f bar. Hey, I'm directly writing. If you're understanding well and good, not understanding, m into g into l into sin theta. Adhe. So this is your torque. Torque should be equals to I into alpha. Ide kada? I alpha is equals to m into g into l into sin theta. Andariki. What is I, sir? Single particle unte I is ml squared. Adhe. M into l squared into alpha should be equals to m into g into l into sin theta. But when we talk about your SHM, angular SHM, theta should be very small. Very small ante theta is small. Theta small unte you can simply say theta is approximately equals to sin theta. Ade kada? Yes. So instead of this sin theta, I will write theta now. So m gone, l gone, alpha is equals to చెప్పండి అందరికి, alpha is equals to g by l into theta. ఇదే కదా? ఇక్కడ నుంచి you compare it చెప్పండి. So alpha is equals to minus omega square into theta, and your omega squared values compare చేసుకోండి. Omega squared is g by l. ఇక్కడ నుంచి your omega is root of g by l. Here time period is 2 pi by omega అంటే 2 pi root of m by k. For your spring, ఇక్కడ వచ్చి your time is 2 pi by omega అంటే 2 pi by root of g by l. And your time period is 2 pi root of L by G. This is the time period of your pendulum. Okay? Everything is completed. Hey, are you listening to me? Hi, Vaishu, hi. Hey, not listening to me at all. Okay, nobody is listening. Hi, Darkin. Hi. Okay. So this omega dash, okay, theta nunchi omega dash vastunnante ante entira? You are simply saying, sir, omega dash is equals to d theta by dt. Ade. Okay, try to understand. This omega, this not, they are not the same. If they are same, you will cancel out and you will be doing all this nonsense stuff. Ardhamaindi andariki? So let us take some questions now. Okay, చూసుకో. Let us talk something about physical pendulum ra. Ade. This is my last discussion. After this, we will discuss 3-4 questions and then we will finish everything. చూసుకోండి. Physical pendulum. Physical pendulum ante entira? Physical pendulum lo you take any general object. It should not be a normal pendulum. It should not be anything. You can take any general scenario. Physical pendulum. Okay. Let us say this is your physical pendulum. Andariki. Okay. This is the hinge point ra. Hinge point ante enti sir ipudu? Hinge point I have explained already in your rotational motion. Rotational dynamics law I have already explained you the hinge point. చూసుకోండి. Let us say the center of mass of this pendulum is somewhere here. Ide center of mass. Ide kada? Yes. Whatever this distance is there, distance of center of mass from hinge, L. Okay, mass is m. Andariki. Mass of this physical pendulum is m. Physical pendulum ante enti sir? You take whatever ఏదైనా తీసుకోవచ్చు. It's also a physical pendulum. చూసుకోండి. This is also a physical pendulum. This bottle, it is moving kada? Yes. So it is also a physical pendulum. లేదంటే any object that is moving to and fro like a pendulum is known as physical pendulum. You're not understanding something. Okay, perfect. So sir, what about the time period? Time period ide kada? This is what the most important thing in any pendulum is. Time period. Formula gurtupettukondi. It is equals to 2 pi root of I divided by m into g into l. Ade. So this is your time period of physical pendulum. Ade kada? We will do some questions based on your angular SHM. some questions based on your physical pendulum, and then this session is completed. Oh, not completed. You'll have to talk about SHM and you also have to talk about your superposition of SHMs ra. Adi kuda chaala important, okay? That's also very important thing. Superposition of SHMs. Andariki. Okay. Let's take a question. Andariki. The question states something like that. A physical pendulum. Leda. Find visible ra, something like this. Okay, mass m is equals to not 10 kgs. I would not say 10. 6/4 తీసుకో. 6 kgs. ఎక్కడ వచ్చి the mass m is equals to 4 kgs. Okay. Yes, Elena, yes. Cheppo. What is the doubt? I ante moment of inertia. Adhe. All the best, wish you all the best. Okay, చూసుకోండి అందరికి. So let us do one thing. Let me just zoom it up. Okay, let me just zoom it a little so that things get cleared for us. చూసుకోండి రా. Okay, first of all, ఇది ఒక ఫిజికల్ పెండులమ్ కదా. సో టైం పీరియడ్ ఫార్ములా ఏంటిరా? టైం పీరియడ్ is equals to 2 pi root of I divided by m into g into L. L అంటే ఏంటిరా? I is the moment of inertia. జాగ్రత్తగా వినండి. I ante moment of inertia and L is the distance of center of mass from hinge కదా. సో హియర్ ఇస్ యువర్ హింజ్ రా, చూసుకోండి. ఇప్పుడు నాకు సెంటర్ ఆఫ్ మాస్ కావాలి, రెండు మాసెస్ ఉంటాయి. వాట్ ఇస్ ద ఫార్ములా ఫర్ సెంటర్ ఆఫ్ మాస్ రా? ఫ్రమ్ ఫస్ట్ మాస్ ఇట్ ఈస్ m2g డివైడెడ్ బై m1 ప్లస్ m2l డివైడెడ్ బై m1 ప్లస్ m2 కదా. m2l divided by m1 plus m2. L is the distance between them. చూసుకో. So center of mass from 6 kg is equals to our center of mass is equals to m2 into d divided by m1 plus m2. d అంటే distance between the two masses రా. From 6 kg అంటే m2 తీసుకో 4. d value is 10. m1 plus m2 అంటే 6 plus 4 అంటే 10. From 6 kg it is 4 meters రా ఇదే. So this distance is 4 meters. And this is your center of mass. Andariki. Ide me center of mass. Now what do I want? L ante distance of center of mass from hinge. Hinge ante, see, this total distance is 10 meters. And this distance will be 5 meters. Ide kuda 5 meters. Ee 5 meters unchi already 4 meters are there. Ante, can you tell me what is this distance? All of you. This distance is 1 meters. Ade kada. This distance is 1 meters. All of you. If this is 1 meter, this is root 80 meters. Can you tell me what is this total distance ra? Pythagoras use cheyali. Pythagoras, root of a square plus b square. Ante L square is equals to root of 80 square plus 1 square. Ante 80 plus 1 ante 81. That means L is equals to 9 meter. Ante L value ochindi ra 9 meters. Ade kada? Yes. You got the value of L as 9 meters. All of you. You got the value of L as 9 meters. Kani you want moment of inertia also kada? So moment of inertia I is equals to m1 r1 square plus m2 r2. రెండు masses ఉంటుంది కదా. So m1 r1 square plus m2 r2. r1 r2 ఏంటి రా? r1 and r2 చెప్పు. They are distances. చెప్పండి. Distances of masses from hinge point. ఇదే కదా? Yes, from hinge. ఎక్కడ కూడా this is the distance of r1 and r2. I am writing it with this color. చూసుకోండి రా. ఇదే hinge first mass, hinge second mass. ఇదే నా value r1, this is r2. ఎందుకంటే symmetries are there, so I'll simply write r and r కదా. Yes, r1 r2 are same రా. So moment of inertia is equals to m1 into r square plus m2 into r square. ఇదే కదా. Yes, చెప్పండి. So r square into in bracket m1 plus m2. m1 plus m2 అంటే ఏంటి రా? r square into 10. ఇదే కదా. Yes, 10 r square. r square కి వాల్యూ ఏంటి రా? This total distance is 5. This is root 80 ra. Root 80 and 5. They are perpendicular. So Pythagoras theorem use cheskondi. Sir, r square is equals to 80 plus 25 and 105 meters. Ade. This is the value of r square and 1050. This is your moment of inertia for both the masses. Andariki. You got moment of inertia. You got length. Substitute cheskondi. Time is equals to 2 pi into root of moment of inertia 1050 divided by mass. ఇప్పుడు ఏ మాస్ తీసుకోండి. what mass will you take రా? what mass to take అంటే total mass. ఫిజికల్ పెండులం ఉంటుంది కదా. total mass is 10 kgs రా. 6 plus 4 10 multiplied by g కూడా 10. length ఎంత సార్? length is 9 meters. అదే. So is it divisible by 9? It is divisible by 3 for sure. So 3 3s are 9, 3 5s are 0. So it is equals to 2 pi into root of 35 divided by 30. Idigo. So this is a time period of oscillation of this physical pendulum. Andariki. Ardhamaindi kada? Very good. Very good. Okay, so this is your total time period of oscillation. Now let us talk about superposition of SHMs ra. చాలా ఇంపార్టెంట్. ఓకే, ఈ చాప్టర్ తర్వాత we will be going on waves. There we will be studying interference of waves, constructive interference, destructive interference. Waves chapter, immediate after the wave chapter we will have wave optics. There you have interference of waves ante fringes. Are you understanding? Maxima, minima, we talk about fringes, we talk about the patterns. I hope you are understanding. So the foundation for each and everything is here. Ante superposition of SHM, simple harmonic motion. All of you, if your superposition is weak, if your superposition of SHM is not good, ante your waves will be very weak, and at the same time your wave optics is also going to be very weak. I can take now also. Later, if you are tired, we can take it from the next lecture also. But for the students who are not tired, let me take it now only. Choose one. Okay, superposition of SHMs ra. Okay, I will anyhow repeat it in your wave chapter. Kani, I want all of you to listen. Superposition of SHM ante simple harmonic motion. Vinandi. First SHM is x1. Second position is second SHM is x2 ra. Okay? First SHM is x1. Second position, second SHM is x2. Okay. X1 is how much, sir? X1 is A1 sine of omega t. What about x2, sir? X2 kosam I am taking a little different. I am talking about A2 sine of omega t plus 5. Try to understand. So, the first terminology that I will talk about is phase difference. Cheppandi andariki. Phase difference. Phase difference is how much? Sir, phase difference is equals to 5. Ide kada, chuskondi. This is your first phase, ra, phi 1. And ide me second phase. Ante phi 2. Ide kada? Yes. Cheppandi. Phase difference ante delta phi. Ante phi 2 minus phi 1. That means omega t plus phi minus of omega t. Ante your phase difference is phi. Delta. Choose code. What common observations did I take? I only taken common as omega. Choose code. Ikkada kuda the same omega untundi. Here also I have the same omega. Other than that, everything is different. And the time is, although you are seeing TTS variables, that time may be same, may not be same. But omega must be same. Okay? Omega must be same. Ide na phase difference. Are you understanding? Now what I have to do is I have to add x1 plus x2. Andariki cheppandi. X1 plus x2 ante enti ra? A1 times of sine of omega t plus A2 times of sine of cheppandi. Ide kada? So this is the addition of your SHM. So to do it, you have to expand it. Ela expand cheyalante, you simply say A1 times of sine of omega t plus A2 times of sine of A plus B. Sine of A plus B. Gurtunda? It is sine A cos B. Sine A cos B plus cos A sine B. I hope you are understanding it. And it is simply equals to A1 times of sine of omega t plus A2 times of sine of omega t cos phi plus A2 times of cos of omega t sine phi. Let us rearrange the terminologies. Let us rearrange the terminologies, and if you are understanding, try to understand, all of you. Okay? So I am writing A1 into sine of omega t, okay, plus A2 into cos phi, okay, A2 cos phi into sine of omega t, right, plus A2 into sine phi, right? A2 into sine phi into cheppandi cos of omega t. ఇప్పుడు ఏం చేయాలి సార్? You take out common, whatever it's common. Sin omega t is common kada, so I'll take sin omega t common and I'm left with A1 plus A2 cos phi chepo sin of omega t plus, tell me what is left, plus what you're left with is A2 into sin phi multiplied by omega t. అదే కదా. ఫర్ సమ్ టైమ్ అందరికి కొంచెం సమయం తర్వాత కొంచెం సమయం కోసం ఐఎమ్ టెలింగ్ యూ దిస్ వాల్యూ, ఈ మొత్తం వాల్యూ అంటే లెట్ us take for some time it is equals to a ray, a and ఈ మొత్తం వాల్యూ let us take some for some time it is b, ఎందుకంటే మొత్తం కాన్స్టెంట్స్ కదా. ఎస్ చూసుకోండి, a1 is constant, a2 constant, phi కూడా constant, a2 constant, phi is also constant. Phi అంటే ఇనిషియల్ ఫేజ్ డిఫరెన్స్, it's not going to change, కాన్స్టెంట్స్ రే. సో మరి ఏం చేయాలి సార్? యువర్ ఈక్వేషన్ గెట్స్ సింప్లిఫైడ్ టు దిస్. చూసుకోండి అందరికి, యువర్ ఈక్వేషన్ గెట్స్ సింప్లిఫైడ్ టు దిస్. సో యువర్ x net comes out to be a times of What's happening? X is equals to a times of sine of omega t plus b times of cos of omega t. Now you try to understand. Okay, you try to understand. Mathematics law, you have a whole chapter, but you are not math students, kada? So they do something, JEE people, they do something. Okay, what they do is they do have trigonometry and e expressions. Okay, they do simplify it, something like this. Chusko. Whenever they have a sin x plus b cos x, what they do is not theta plus b cos x. What they do is they write it something like this: sin of x plus pi multiplied by 1 by root of a square plus b square. This is how they write, right? This is how they write. Okay, this is how they do it. Okay, this is how they do it. So what do they do, sir? What do they do and then? So what you have now here, you have everything. Okay, you have everything, right? So instead of a, instead of b, that you have, what do you write, sir? X net is equals to, you write sine of x, x ante enti ra, x ante omega t. Okay, x ante omega t. So sine of omega t plus some phase constant. Now we will not take phi, let us take some constant alpha ra, multiplied by 1 by root of a square plus b square kada. Chuskondi. Root of a square plus b square ante enti ra? Cheppandi. Okay, so just a minute. Okay, it should not be divided by, it should be root of a square plus b square. Other. So similarly, you can take root of a square plus b square. Can you write the values of a and b? A is this, b is that. Okay, so a1 plus a2 cos pi whole square plus a2 sin phi whole square. Yes, plus a2 sin phi whole square. So this is your x net is equals to, if you want to solve it, you can solve it later. You call it total to be a net, okay, a net into sine of omega t plus some angle alpha, some angle. Okay, they do it something like this. Choose. So here onwards, you say an is equals to root of, if you want to simplify, you simplify. I'm directly writing this. Choose a1 square plus a2 square plus 2 into a1 into a2 into cos phi. Hey, what is happening? Hey, this is how the value of a net looks like. Choose. So, ante mee daggara superposition of SHM unte, this is how you do the stuff. Okay, right. So malli okkasari cheptunanu chuskondira andariki. So if at all you have two equations of SHM, and me x1 value, x1 is equals to a1 into sine of omega t, me daggara x2 value is equals to a2 into sine of omega t plus phi unte, when you are adding these two, ante x1 plus x2, choose you have amplitude a1, a2. When you are writing x net, you write the amplitude a net and you write sine of same omega t untundi kada, omega t plus instead of this phi, write some angle delta, leda alpha. Okay, what is the value of alpha, sir? The value of alpha will be, chuskondi, ekkad nunchi. They do something like that, right? Math, JEE people, right? They do have some mathematics, okay? What they do is, chusko. You have sine, okay? You have sine kada, sine A cos B plus cos A sin B, ante they say sine of A by B ante A2 sin phi divided by alpha is equals to tan inverse of A2 sin phi divided by A1 plus A2 cos phi. Okay, this is how the value of alpha is written. Andariki. I don't know if I should. That's why. Kabatti I was, getting a little scared to tell you all these things because it's a little headache process. Okay, A net into sine of omega t plus alpha value into A and t. This is the alpha value, and you can simply say A net is equals to root of A1 square plus A2 square plus 2 A1 A2 cos phi. Choose. A ante amplitudes of SHMs. Okay. Now, when you are starting with waves, I will be starting from this point. Okay. Ante superposition of SHM. We will start from that point only. Right? Perfect. So the question is like this. Choose one. Yeah, IP 4 marks. I don't know how these things are there. But in your JE also, Leda, your NEET also, it asks with a great detailing, okay? Great detailing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just two SHMs, simple harmonic motions. Correct. So let us try to do that question. Choose one. So when I'm adding the two SHMs, What were the equations? Standard equations cheppandi andariki. Okay. The standard equations were x1 equals to a1 times of sine of omega t. Second equation entira cheppu, x2 is equals to a2 times of sine of omega t plus 5. Kani question lo chudandi, one is given in sine and I don't have any problem with it. Kani idante it's given in cos kada, so I'll have to transform it. Ela transform cheyalira? Sine of x is equals to cos of pi by 2 plus x kada. Yes. Sir, transformation ante you can say cos of x is equals to sine of pi by 2 minus x. Leda you can also say sir sine of pi by 2 plus x. Ante kada? Yes. Sorry. So your cos of this becomes something like this. So your cos of pi by 2 into t is equals to sine of pi by 2 into t plus pi by 2. Ide kada? Yes. Good. Very good. Now cheppandi, what is the phase difference, sir? Phase difference ante ide na first equation ra chuskondi. Your first equation is this. The first equation is x1 is equals to a1 value enta icharu sir, 4 into sine of pi by 2 into t. Ade kada? Yes. Second equation cheppandi. Second equation x2 is equals to 6 into sine of pi by 2 into t plus pi by 2. Cheppura, what is the phase difference, sir? Phase difference is pi by 2. Delta phi is pi by 2. Delta phi phase difference is equals to pi by 2. Either you can simply say, sir, your net amplitude A net is equals to root of plus 2 into A1 into A2 into cos phi. ఈ ఫార్ములా గుర్తు పెట్టుకోండిరా. ఇఫ్ యు ఆర్ లూజింగ్ ఇంట్రెస్ట్ ఇన్ దిస్ ఫార్ములా బికాస్ ఆఫ్ ద ఎండ్ ఆఫ్ ద లెక్చర్ సార్, లాస్ట్ 10-15 minutes ఆర్ దేర్, వాట్ యు ఆర్ మిస్సింగ్ టూ మచ్ రా. యువర్ ఇంట్రెస్ట్ షుడ్ రైజ్ నౌ ఓన్లీ. యూ షుడ్ టేక్ ఇట్ వెరీ కేర్ఫుల్. ఓకే, జాగ్రత్తగా. ఫై అంటే డెల్టా పై అంటే పై బై 2 కదా, కాస్ 90 0 అంటే ఇది అన్నిటి మొత్తం ఇట్ గెట్ 0 రా. యు ఆర్ ఓన్లీ లెఫ్ట్ విత్ a1 స్క్వేర్ ప్లస్ a2 స్క్వేర్ అంటే రూట్ ఆఫ్ 4 స్క్వేర్ ప్లస్ 6 స్క్వేర్ అంటే 16 ప్లస్ 36 రా. అదే, సో ఇట్ ఈస్ నథింగ్ బట్ రూట్ ఆఫ్ 52. దిస్ ఈజ్ యువర్ a net. అందరికి ఒకసారి a net వచ్చిందంటే యూ కెన్ రైట్ ద ఈక్వేషన్ ఆఫ్ SHM ఆల్సో. వాట్ యూ కెన్ రైట్ సార్, చెప్పండి. సో ద ఈక్వేషన్ ఆఫ్ SHM is, the resultant equation of SHM is given as, చెప్పండి, your x net is equals to a net అంటే root of 52 into sine of omega t. omega t అంటే అదే pi by 2 into t plus some angle alpha ra, alpha. What is alpha, sir? Alpha is equals to tan inverse of, చెప్పండి, a2 sin phi divided by a1 plus a2 into cos phi. ఇదే కదా. Tan inverse of a2 value ఉందారా, you also have to remember this formula. Okay, a2 value is 6 into sin phi అంటే sin 91 divided by a1 అంటే 4 plus a2 into becomes 0 అంటే your alpha is tan inverse of 3 by 2. If you want you can substitute, లేదంటే leave it as it is. So x net is equals to root of 52 into sine of, చెప్పండి, pi by 2 into t plus tan inverse of 3 by 2. So this is your resultant of SHM equation. Okay, with that being said, we will stop for today's session. Andariki, so it was really nice having this session with all of you. The class lo your entire simple harmonic motion has been completed. Okay, whatever things they are remaining, or if I am forgetting something, tell me. Okay? I know, but if I am forgetting something, tell me. Yeah, we also don't know, sir. How will we tell you? We only don't know. You are expecting us to tell. How will you tell, sir? Do you think we are that much smart? We are not smart, sir. Who told you we are smart? It is whatever it is, just it becomes 0. Okay, fine. So if you don't have any problem, we can end this session. Okay, all of you. Finished. Class complete. Okay, class completed. Andariki. So repu we will take waves. waves will take a little longer. It's a little difficult chapter. Hey, all of you, when you are preparing for waves, your SHM must be very good, okay? Your SHM must be very good. Or else you will not be able to understand anything in SHM. Okay? Okay. Okay, AC generator and mutual inductance is remaining kada. Okay. Let us see. AC generator ante, this was your class 10th lo. You do have that motor kada, electric motor. That is your AC generator. As I told you that in your AC generator, what happens is your flux is changing, but you change that flux by changing the direction. Okay, whatever it is, let us take it. Okay, but not for now. I'm extremely tired for now. Okay, let us take it some other day. Bye, 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 all of you. Bye, 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 bye. Yes, thank you so much, Parimula. Thank you so much. Thank you so much for that comment. Okay, all the time. That is the only comment I get. Okay, bye, 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 all of you. Bye, bye. EM waves will be on any of the holidays, Ram. Okay? EM waves, we will be completing EM waves on any of the holidays, not for now. Perfect. Good night, all of you. Good night. Good night, good night, good night, good night, good night. So I'll end this session. Okay? Don't have any doubts? Okay? We can end it. Okay. Bye bye, all of you. Bye bye, bye bye, bye bye.